you.
There you go.
Yeah, I got it.
Winch all stop.
Okay, I'm going to keep pushing down. You can get back on the winch.
Copy.
Good morning, Deep Sea Explorers. I'd like to welcome you to Dive 19 of the NOAA Ocean Exploration Expedition, North Atlantic Stepping Stones. And today we're stepping on Retriever Seamount, which is actually inside the Northeast Canyons and Seamounts Marine National Monument today. We're starting at a depth here of 1,900 and looks like 20-30 meters. We're just seeing the bottom, and we're going to let the pilot set up here, and then we'll begin our dive.
Yeah, you can keep coming down, Chris.
Copy.
Your delta's really high.
I'll stay here until you come down a little further.
Yep.
Curious what that circular object is.
All right, that's a delta 20 there.
You can push and hold to reset that, by the way.
Yeah. I was at 60, so I had to get to 30, so either go down or go up 30. Okay, let me get to the bottom here. You keep paying out in the winch a little more.
Copy.
Give me to like a delta, 17 or 16 or something like that.
Copy.
Bridge RV now. Vehicles on bottom. Yeah, so we were thinking 060 or 070, whichever works better for you. Okay, let's do 070. Copy.
Okay, good job, co-pilot. That looks good.
Copy. Off winch.
I can start deploying my swing arms.
Good
As
copy.
I get my Z-bias dialed in here.
Do you have a preference, uppers or lowers first?
Oh, whatever.
Okay. Jaws coming on. Uppers coming out first.
Sirius salinity is bad again.
Yep. Eagle has landed. Hey, watch lead. This is pilot.
Pilot, this is watch lead.
Hey. So we just acquired bottom. I got my co-pilot getting the swing arms out, and we are almost ready to start the dive.
Excellent, perfect. So the first task, like all our dives, is to find a loose rock, and I think we saw a few as we came down, so hopefully that won't be too hard a task this morning.
Copy that.
Thank you.
We have an abundance of choice today.
That doesn't often happen, but it does look like we have an abundance of choice.
Are any of these rocks good candidates? Or was there a different section of larger rocks that you had your eye on?
Can we have the lasers on to look at some size?
Yeah, absolutely.
Thank you. Jason, how are you feeling about these rocks right here in between the skids?
Lowers need to be fully out before we deploy.
The one with the operator on it, or the one with the laser?
Copy.
Yeah, one with the lasers looks nice and angular.
All right,
Yeah,
lowers are
I think
fully
we'll take that
outboard.
Yeah, I think that's a good
Flying
target,
down.
please, pilot.
Understood.
Thank you. Interestingly, on the bottom here, too, I can see some old Desmophyllum dianthus, some fossils, some fossil corals that we've seen in a few other places. And certainly a ton of ophiuroids, these brittle stars, all draped all over the rocks.
Okay, I increased the
Good
RPM
morning.
of the hydraulics.
Good morning,
Copilot.
afternoon, and evening, everybody.
Copy.
I'm going to give this one a poke, see if it's loose, and then I'll open the back box.
Copy.
And then if you want to take your rotator and
Yeah,
rotate
those,
down so you can see
Carpals aren't even
Good
very
copy.
covered with
then let me
manganese.
know if
The
Sirius is on the
ferromanganese
move.
crust. So.
Hydraulics coming on.
Yep, that one looks loose.
Okay, you want to report wing inboard?
Copy. Coming inboard.
Go ahead, Bridge.
Video, if you want to come in. Well, actually, is this a sufficient sample?
How does that one look there, Jason?
Copy, that's fine.
Oh.
They're going to shift their heading like 2 degrees.
Okay.
Wait for it to focus. Yeah. I think that one's okay. Looks like it might have a little crust on it, so that's good.
Nice. That sounds good. Thank you, pilots.
Understood. Video can come out and I'll put it in the port forward rug box. I'm going to take my mini Zeus so I can see what's going on here.
Excellent collection. Thank you so much, pilots.
Yep.
Before we leave this spot, there's a small little coral over in the bottom right-hand quadrant. It'd be great to have a snap zoom on.
Understood.
Thank you.
Okay. Oh, I think I see it. It's partially translucent one.
It is. It's very hidden amongst these rocks. I know there are a lot of
It's coming in
larger
video.
species up on top of the rock, but sometimes it's nice to zoom in on these smaller ones and see what we have. Oh, looks like a bamboo that's absolutely covered in crinoids. Fine little bamboo with more crinoids than I think I can count. These crinoids have climbed up the skeleton. I can still see some of the bamboo is alive underneath.
Okay.
It's still got tissue all the way to the base.
A little bit of swing. Big fish up there, see it?
Huh.
In your view?
They do.
Thank you so much, pilots.
Video can come out.
Yeah, where is that fish? I can see it in Sirius.
I think it's significantly above me. We got 21 meters between the two vehicles right
Okay.
now, so it's somewhere in that range.
Well.
Judging by the fact there's no light on it.
We're certainly seeing a number of different colored pebbles and other things on the sediment. Throughout most of these dives, it's been ferromanganese crusted pebbles and cobbles
Fish center,
on the sediment.
lower
But here
right.
we'll see all kinds
Take
of
it video.
colors. Hopefully we'll get to find out what is the source
It's
of
gone.
of these
Okay.
materials. Certainly we're interested to know if we
I'm
have
going to push ahead, co-pilot, so you can
novice,
rotate up with me.
Copy.
such as basalt up at this depth, or whether we're seeing carbonate
You can
material.
finish off
And,
your swing.
one of the things we're hoping to
Yeah.
get from this dive, some information on that. A lot of marine snow today. That's the material in the water column that the lights are reflecting off. I don't know if it's probably close to the most amount of marine snow that we've seen on a dive.
Yeah, I would agree, Jason. It does definitely seem to be a lot in the water, and certainly where we've landed here too. There's a lot of coral communities and a lot of sponge communities
You can
here.
rotate it more.
I've already listed
Keep
down
me at like the bottom of your screen.
6, 7, 8
So I can
species
look
of
ahead.
coral so far,
Roger.
just on our little landing spot here. Absolutely beautiful.
Yeah, I like that. That's
And certainly having more marine snow is expected, given that we're now quite close to the eastern North American continental margin. So, we have material coming from terrestrial sources, which we didn't have certainly when we're in the corner rise and in the eastern New England seamounts. But we're seeing a lot more of that now, contributing to the excess marine snow.
Go ahead. Okay.
Just going to do some little zooms on some of these corals, try and get some identifications. As Scott had mentioned in the pre-dive call here, that we might get some species that we haven't seen so far during this expedition, which would be really fabulous.
Video can come in on this one. This coral colony.
Delta's a little low coming up.
No, it's okay.
Yeah, and this is a black coral. Potentially a Leopathes, but I'll wait for the scientific chat room in the background here to help give me a name on this one. These black corals have these very black skeletons, and you can just kind of see that black skeleton through the orange tissue, particularly where it's broken a little bit. One of the other features of these black corals is they have these very long, drippy tentacles. So you can really see those within this branching here.
Said like 10, 15 years.
Stauropathes. So
Okay.
Scott
And
France
as he
is
goes
saying that
farther
this is a
out,
Stauropathes
I'll
black
come
coral.
down,
Right.
and
It
then
has,
if he comes underneath me, I'll
There's
come
a
up.
barnacle on
Just
the
to keep
side
the
there.
tether
Video do you want
Growing
to
on it.
out of
Specs.
everything in
Understood.
the wash from Sirius.
Yeah, it
You,
might.
you said several times that the black corals are so named for the skeleton. I could see there on the left side a couple of places where the skeleton's been scraped, and you can see that bright black showing through the tissue, just below the barnacle.
Yeah. It's actually, it might be a hydroid, Roland was just saying, rather than a barnacle. I can kind of see the pink. It's very, very, very well hidden in amongst the skeleton here. Beautiful.
Thank you, video. You can come out.
Yeah, thank you so much, pilots.
Get a full screen of it.
Okay.
So Stauropathes on this particular black coral. And actually, this is a great visual of this rock here, and you can just see the amount of life that's right here. We have ophiuroid brittle stars covering the bottom. We have the crinoids up on top of the coral. And then we see, potentially bryozoans or hydrozoans colonies also growing all over this rock as well. Looks like an old crinoid stalk. Oh, can we zoom in on
Like
the...
a pretty stiff current coming there from the right side to the left by the looks of all those hydroids tipped over.
Go ahead, Watchley. Yeah. Video, can you snap in on looking for something yellow? I can get closer once I identify which subject.
I didn't hear the subject matter.
Yellow in color. I'm not sure which one yet.
Yeah, kind of up in the back there a little bit. There you go. Lasers are just below it. It's very large.
Oh, okay. I'll get closer video.
Thank you. We can see these beautiful metallogorgias, these corals that are up like a little umbrella or a pom-pom on top of a stick. I can see both a juvenile one and an adult one. The juveniles have these branches going down their long stems, and the adult ones have lost those branches and just have this big umbrella or pom-pom on top.
Rian, were you about to zoom in on where the lasers were?
Yes, yep, they're just getting a little closer, Scott.
Okay, I think that's an Acanthogorgia, and then behind it to its left, I believe, is an Acanella.
Yep, I think so too. They're just getting a...
So this may be the first Acanthogorgia, right?
It is, yes, this will be the first one so far on this expedition. Yep.
Cool.
There we are, right on the lasers now.
This one. Come in video. A little bit of current, so I'll see what I can do.
And in fact, as we zoom in, I think there may be 3 Acanella in this area. So interesting abundance as well.
Yep, and here's the Acanthogorgia.
Yeah, very recognizable because the polyps stand out from the senenchyme, which is the tissue that's wrapped around the branch, and they don't have these anthostele, these little mounds that they retract into. Earlier, and I'm sure we're going to see them plenty today, we'll see the Paramercia sea fans, which have a similar color, but they have these little mounds that the polyp can completely retract into, not so with Acanthogorgia. And if at some point here or on some other colony we get a really close-up view, you'll see what is referred to as a collarette of spines that, a lot like some of the bamboo corals, they have this really spiny set of sclerites that surround where the tentacles are presumably for protection.
Watchley, was there another subject you wanted
Beautiful.
to...
No, I think this is good. We have definitely an Acanella in the background there.
Okay.
And lots of this Acanthogorgia, actually, Scott. I can see it kind of dotting all over the rock face here. And there was a Paramercia just coming into view as well on the left-hand side, as well as a Hemicorallium. I can say my list of corals that I'm writing down here is getting long already, and we haven't even moved off our landing spot. So this is wonderful.
Yeah, I fear you're going to have a sore hand today.
Yeah.
Do you want me to follow you over, pilot?
I think, on our previous research dive on this seamount, somewhat deeper than this, Acanthogorgia was very abundant in places. I mean, dozens of colonies all crowded in together. So I'm not at all surprised that we finally picked it up on this expedition here on Retriever.
Yeah, absolutely. And it's definitely, there's multiple colonies on top of this rock face here. Beautiful.
I might make the first move kind of
following if you need help writing down the corals, I think biology is going to be very abundant today. Might not be as much geology to cover, so just let me know.
Absolutely, Scott. Absolutely, Jason, sorry. Oh, we have a fish up here in the water column. Oh, off it went.
Got frightened.
Rian, after the fish, there's... No, I'll let you go for the fish.
Yeah.
Okay, I'm going to go acquire that rock again.
We're back. I'm just going to note that the whip in the distance there looks like it has a branch, which is pretty unusual.
Big fish.
Yep.
Yep, the branching there sticking up. Oh, and a fish as well.
Drifting towards you.
I'm driving towards it.
Is that a new one for this expedition? I don't think we've seen that one.
This fish here, we may have seen one of these before, but I'm desperately trying to look up the names. If any of our fish biologists on the scientific chat room in the background...
I'll go out on a limb and say this is a hake of some kind.
Okay.
And usually when I throw out the wrong names, that stimulates the fish biologist. The right name.
Yep. Looks like quite an old fish. Has lots of scrapes and scars on its side there.
I like the spike on its chin.
I imagine that elongated dorsal fin will be diagnostic.
Yep, and Peter Oster is saying a gadiform, so Lepidion. Thank you, Peter. And yep, and Ken Sulak is confirming that Lepidion is indeed a type of hake. So there you go, Scott, you were correct.
Through the screen.
Sometimes even random guesses have to be right.
Absolutely. Thank you so much, pilots. That's great. And there was a
That's why I
long,
generally stick with it.
yeah, there was a long bamboo whip there with a branch on it. That'd be great to have a little zoom in on.
Okay.
And if you've just joined us, we've just landed on the bottom on Retriever Seamount. This is Dive 19 of the NOAA Ocean Exploration Expedition, North Atlantic Stepping Stones. I'm Rian Waller. I'm the biology lead on board here, on board the Okeanos Explorer for this expedition. Jason
You want me to
Chater
come
is
down
on the
a little,
line.
give
He's
you a
the
little bit
geology
more?
lead for
Yeah.
this expedition.
Copy.
And I say we've just landed at the bottom. We're at
15
1,932 meters
55.
on this dive on Retriever.
Copy.
And we're very fortunate today to be diving inside the Northeast Canyons and Seamounts Marine National Monument. And I believe
Yeah.
on the line or online soon we'll have Brittany Peterson, who's the superintendent
Bridge, yeah.
for the monument. Tell us a little bit about the monument
I'd
itself.
like to request a ship move. 15 meters.
Yeah, hi, this is Brittany Peterson with the U.S. Fish and Wildlife Service,
speed
Superintendent of the
decimal
Northeast Canyons and Seamount Marine National Monument, and the first marine national monument in the Atlantic. Very excited to get to see
correct,
see
thank
this
you.
today and see the creatures, the corals, and just geology of this amazing place that is just under our surface and just off the coast of Cape Cod.
Yeah, thank you so much, Brittany. We're super excited to be here as well as scientists and be able to look at these
Thanks,
seamounts
Pat.
within the protection of the national monument.
Keep an eye on your sonar. Your port side, there was a little bit, that little rock there, but
Yep.
it wasn't super tall, so not concerned about it, but keep an eye.
Copy.
All right, come in video.
So thank you for this close-up. One of the reasons I was remarking on it is that, it clearly has this whip-like growth form, but then you can see there is this one branch that's pretty high up on the colony. And one of the things we still don't know is whether we occasionally see these forms that have, I call them
Partial
forked whips.
Yeah.
What we still don't know is whether
current
this is a
toes,
particular species that only
sliding.
starts to put out secondary branches after it's grown to quite a long, tall size, and so it would be relatively old as a whip and then branch. You can see that it's more than a meter up before it starts to branch. Or if this is some response to damage early in its life, and as a response to that damage, it's put out a branch. Earlier in the expedition, we were seeing those, what we were
Trying to
called
get that
cages
branching
around the
point.
anemones, and the hypothesis there was the anemone had caused some damage, which was affecting how the coral responded and grew. But this is a bamboo coral, and one of the things that's very plainly obvious is a huge density of polyps. The polyps are really packed in there together. I would say more than almost any of the corals, bamboo corals that we've been seeing earlier. I can see on the right there some very prominent spines, much like Wolverine, the Marvel character, that arise between the tentacles. So this will be really useful for trying to ID it.
Hold
Thank you
that
so
for a
much for
little
that
bit.
close-up.
Yeah, this is beautiful, Scott, and I will, say the same, that I think this is the densest of these bamboo whips that I've seen in terms of the polyps. Really, really densely packed on the skeleton. Just beautiful. Crinoids sitting on top, or near the top.
Les Watling in the chat room has offered that this may be in what we're calling the B clade. That would be related to keratoisis. B clade is referring to some genetic analyses that we've been doing on bamboo corals from around the world, and we're using the
Full
genetics
wide.
to help us sort the different species
Large
out
colony.
into groups. And if it is the B clade, one thing that's interesting is, 2 dives ago,
Let's get
we
lasers
were
on one of the
seeing
branches.
those corkscrew type bamboo
Go back.
whips,
Can you turn my lasers
and
off?
those were also B-clade and also had a dense
Bottom right.
coverage of polyps. So that's sort of all coming together.
on.
This is why we do the genetics, and we can compare it back to all these wonderful video
See if I
images,
can't find my
so we can
lasers.
start to better understand what these
I can-
things look like
maybe I
and
can
how that
splash them
relates
at
to
the
their
base.
genetic makeup.
Hold on.
Here we're going to look at the very base of this bamboo here. And it's got a really interesting base. Really fascinating. What are those?
Yeah, well, snails or
I don't think they're snails. No, they've been calcified over almost.
Excellent.
I wonder if they're little
are they eggs?
eggs, potentially little tunicates. I can see a slit at the top of one of them.
For your last
I don't
bridge?
think I've ever
It
seen.
does look like it's something that's been in place that almost looks like the tissue of the bamboo coral is growing over it.
Are you
It's so
saying they're
old.
complete now?
Yeah, there
That's what I
seems to be
thought.
some that have been calcified over. Really interesting.
Thanks, video.
Von der Wareham is
And I
saying
did
these
not
looks,
approach your last
yeah.
Supporting egg capsules of
Right,
some
thank you.
kind, Rossia egg cases. Vonda, I'm not sure what Rossia is. If you could
Can we
add
hold
that
this
note.
shot?
Sure.
Really fascinating. They would have been grown over by the coral itself and then eventually calcified over as well. Doesn't seem like that's a great place
so
to lay your
it's
eggs.
an interesting observation, Rian, that the tissue for many of these corals, just as it does on the rock itself, is able to sort of grow out, and it's the tissue that's depositing the calcium carbonate. And so,
Shot's clear.
Okay.
to the
Thanks.
coral, that's just part of the rock bottom, the seafloor, and it's sort of growing over it. I don't know how stable it is.
Look at the purple.
Yeah, so Von der Wareham is saying a bobtail squid
Sure, we'll give it a
is
snap.
the
See if we hear
Rossia.
interest.
So potentially squid eggs at the bottom of this bamboo coral, which is a really fascinating observation. Thank you so much. Here we have this beautiful deep purple, royal purple clavularia. And this is a species of coral that actually encrusts and grows over structures. And I can see on the base there are some of these fossil corals. We were seeing these fossil Desmophyllum dianthus that are covered over in that ferromanganese patina. And so you assume that there's a big aggregation of those fossils underneath. And here we have sponges, several different kinds of sponges. And we have the clavularia, and we have another stoloniferous octocoral in the front here. I can just see the poking out little claws of one of these squat lobsters as well.
Thanks, video.
And a polymastia sponge as well, these little hedgehog sponges that we saw in abundance on our last dive. Yeah, and here you can quite clearly see those fossil corals, those Desmophyllum dianthus sticking out. And those are corals that have been here for a very, very long time. That ferromanganese coats over about 1 millimeter per million years. And so those are corals that
Take it
lived
off.
here a long time before.
You're full wide.
Thanks.
Beautiful. Anthomastus in front of us as well.
It's amazing the amount of diversity that is right here on Retriever Seamount, and just the amount of life
Go ahead.
that is here on the Seamount. It's incredible.
Yeah. Big snap black coral, yeah.
Yes, Brittany, the diversity here is really amazing just in this landing spot to have landed in such a great area. We knew this pinnacle really had the potential of being a great area for these suspension feeders and filter feeders, really increasing that water flow around this conical shape. And here we are.
We'll keep moving.
Beautiful.
We've made this comparison a few times to how corals are analogous to trees of a forest because they provide this habitat structure, this three-dimensional structure that allows other animals to get off of the bottom. I would say what we're seeing here is more like a tropical rainforest where almost every tree is a different species in a small area. It's not like we're seeing all maple trees here. There's just tremendous diversity.
Pretty good return there.
And that, in
Up to
turn, leads to a
port,
diversity
should be right
of
in
the
front of you.
associated
Okay.
fauna, because some of those fauna are specializing on certain types of corals. So,
Unless they're
yeah, a
actually-
really exciting spot.
Yeah,
That's a
absolutely.
great description. I love that comparison.
Yeah, that is great. It's, so a lot of these corals and sponges, we've said it a few times over this expedition, but they are what we call ecosystem engineers. So they're engineering an ecosystem for other organisms to be able to live around them. Just their structure up in the water column, it interrupts the flow of water, interrupts sedimentation, and creates all these great little nooks and crannies for other animals to be able to live in. And so where we see a lot of these deep sea corals, we do often see a lot of other life as well. On some of these deep sea coral areas, thousands of associated species have been recorded around these species of coral. So they're just great areas that create these biomes in the deep sea that attract this other life. Beautiful. Pilot watch lead.
Go ahead. Watch.
Can we have a zoom on this sediment area?
Yeah. Absolutely.
Yeah, kind of down by our right skid.
Okay.
Just have a look at the geology there, see what that is made out of.
Video, you want to come in?
Tilt straight down.
So Jason, this looks like a lot of thicker material. You know, last couple of dives we've seen very fine material, but this looks a lot more dense.
Yeah, you know, we're seeing a lot of fossil coral
Pan around now.
material, branches, and
Yeah,
ferromanganese
you can go on a little bit, Chris.
encrusted
Tilt down.
cup corals, but not everything is encrusted. On some of the dives, all the debris from you know, dead corals, the skeletons were all covered. Here we're seeing basically a range of different levels of this patina, this ferromanganese crust forming. So there's some that are just not encrusted at all, while others are heavily encrusted, showing us this really long-term sort of history of the coral, you know, growth and recruitment. You know, just life in this zone. Even, you know, many of the rocks aren't fully encrusted, as we can see, and you know, we see some you know, quite detailed, complex sediment, you know, that we just haven't been seeing on most other dives, and that's reflective of just how close to the continental margin we are. So, you know, but a much more dynamic sedimentary environment, which you know, is probably reflected in the coral diversity and abundance. And we're probably seeing more food here, and that food generally comes out of the water column. We saw it on the way down, that marine snow, and a lot of different rocks and pieces. So one of the things we have to be careful of on a seamount that's this close to the continental margin, where in the past, the last glacial maximum,
Just like a little local high ground.
quite recently there were a lot of icebergs, sea ice.
Yeah, I mean, you can pull up and do a
So
little scan.
we're going to see a lot more of those drop stones, those ice-erupted debris
I
that
see
we
this.
have been seeing on some of the other seamounts.
And see, that's like a
Certainly going to be denser
So
accumulations
that's a
of
local
those here, just because it's closer
See,
to the
I'm at
source of those
1930.
icebergs. So,
Yeah, that's good to know, Jason.
eyes
You're
up.
looking to the south.
We've definitely seen a few of those ice-rafted debris on previous dives. So it's good to know we might see more of those now we're a little bit closer. The fossil corals are really quite fascinating, you know, some of them being very dark, because you're right, on the previous dives, you know, most of the ones that we were seeing were that dark black, so suggesting they've been in place for a very, very long time. But yeah, they're definitely more of kind of the brown that haven't been quite fully encrusted over yet, and even some lighter skeletons. And so I really wonder if we're going to see some of these hard corals that we're seeing in the fossil record, whether we'll see more of those alive as we make our way up here on this dive.
Yeah, we'll just keep doing 225 until we...
yeah, and some of the zooms we've done so far, they were on the
Like
corals.
15,
But, I was taking advantage of that and looking at the rocks underneath. They, you know, they seem to be, at least the ones we looked at, a little bit layered, in finer scale layers than
Bridge, RV
we would have seen previously
Like
with
to request a ship
volcanic
move.
flow morphologies. So I'm
Range
wondering,
15 meters. Bearing 225. Speed decimal 2 knots.
if we are actually seeing you know, maybe a carbonate material up here at the pinnacles, which would suggest that they are were formed by some sort of erosion paths when the seamount was much younger and closer to the surface. So
Chris, what I'm seeing is kind of a local high to my left here, which is here.
Yeah, on this
And then
rock
we're
here,
gonna
we can see
continue to
several
the
of
main
these
flow.
Metallogorgia, these
Like a local
umbrella-type
high.
corals. The one on the right seems to be more of a
Here.
juvenile. I think it has some of
Get
the
main
the
feature.
branches going down its main
It's a lot
stem,
going down,
and
but it's
then
not
two
really
on the
down,
left
down.
are these adult forms where all of the polyps, all those branches have broken away on the stem and left kind of this pom-pom, this umbrella at the very top of its skeleton there. Some larger pieces of coral here on the laying on the ground. I know where we've seen these deposits of these broken coral branches, it usually means there's something up above us, and we're making our way up today. So today's dive, we started here at 1,931 meters, and our goal today is to try and make it to near the top of this feature, this pinnacle that sticks out on the northern end of Retriever Seamount. Oh, it's a sea star. Very rounded sea star here, a little bit tubby.
Sea stars couldn't miss out on the show today.
Yes. Yeah, the sea stars need to have their moment of fame as well. Yeah, this one looks a little bit different from any that we've seen before, which is interesting. Very, very rounded form. I don't know if that means that it's just had a meal or whether that's just the form that this particular sea star takes. Beautiful. Thank you, pilots. That's great.
Yep.
Something fuzzy on that coral upper left.
And unlike some of the forms that we've seen, we could often see the 2 feet underneath the sea stars. These ones are definitely tucked all the way in.
Roland, should I turn my lights down
Christopher
a little
Ma,
bit
who's
to
an
help
expert
with the
in
port
sea
minute?
stars at the
No.
Smithsonian,
Or do you
says
like
this
them
is
at
a
100%?
contraster.
We needed
Contraster
this
sea
for
star.
the main cameras.
Okay.
And we can see up on this rock here, we have these sponges and what I think is a hemicorallium. Beautiful.
Is that an urchin on the upper left? On the tip of the coral?
In my line. Gonna float over there, Roland. How's Sirius doing in that move? Do you feel it yet, or?
Yeah, I don't think it's really done much, to be honest.
Yeah, that move only started
Pilot
3
watch
minutes
lead?
ago.
Go ahead.
Can we zoom in on this coral on the very left-hand side? I think there's a very large urchin.
Yeah. I'm just gonna get my
We have some lasers on too.
get set up for that.
Thank you.
Stand by one.
Be good to see underneath of it. We might see the mouth parts.
See what I can do for you.
I think you may have came too far left.
Okay, come in.
So I think on the side of this coral here, there's this very large urchin. And so we know that urchins and some sea stars can be predators of deep sea corals. And so we do sometimes see them on the branches. And where we see them on the branches, they tend to be what we call denuded, so don't have any of the polyps, any of the live tissue around those branches. And so you can see underneath this urchin here that there are no polyps on that particular branch, but the one beside it there are. So you wonder if this urchin is having a bit of a munch here. And this is a hemicorallium. We've seen several of those so far on this expedition. We're kind of looking at the back side, so the polyps are on the other side.
Thank you, Bridge.
And this very spiky urchin, a Okeanos,
that move just
Christopher
ended.
Ma confirms.
Okay.
You can see those really hard spines intermingled with these softer, almost tentacle-like protrusions. Beautiful.
Another thing you can see there, Rian, where the branches are broken off, this really solid skeleton to these hemicorallium, and they're extraordinarily dense and tough, and they can be polished and quite different from a lot of the other octocoral skeletons in their construction.
Absolutely, and I suspect some of the skeletons that we're seeing down below are actually of this hemicorallium as well, because those skeletons are so thick and tough and really persist through time. Looks like a branch was actually broken relatively recently. I can see a branch on the seafloor there with actual living tissue on it, which is a little bit unusual to see sometimes.
Snap it.
I think it's the one to the left.
Oh, and up above it on the rock, there might be a live cup coral.
Oh, there it is.
You see that hemicorallium branch, no doubt from the colony that was just above it. And just tucked inside this sponge is a live scleractinian. I believe this is, oh, maybe not alive as we zoom in. Nope, that's alive, so I can see tentacles. So that's a Desmophyllum dianthus. This is a hard solitary scleractinian. So a lot of the corals that we've been seeing so far are what we call colonies. So they have multiple polyps, multiple tissue, and those polyps are all genetically identical to one another. But this here that we're looking at is a solitary coral. So it's living by itself. It's genetically identical, genetically distinct, from its neighbors. And you can just see those beautiful tentacles sticking out through those white parts. They're called septa, and it makes a skeleton of calcium carbonate. And unlike a lot of the corals that we've seen recently, which are either black corals or octocorals, that have a skeleton and then tissue surrounding them on the outside, these scleractinians actually have the skeleton on the outside and the tissue can retract inside it. Beautiful.
These are just crinoids on that skeleton.
Yeah. You know, these crinoids using that dead skeleton.
Okay. Next video.
Beautiful. Thank you, pilot.
Yep.
So there we go. So we've been seeing some of those Desmophyllum dianthus that are blackened and fossilized over on the seafloor when we zoomed in there, and now we've just seen a live one. So maybe there are more to come as we work our way up this transect. Just this beautiful view of deep sea corals covering these rocks as we work our way up. So the deep sea coral larvae, many species prefer to land on rocky or hard substrate. They can't necessarily land in the sand and sediment, so they need a hard substrate to be able to land and grow. And so you can see here where you have sediment in between that's more devoid of species, and then as we have these rocks pop out, we have more species that grow on them. Just beautiful.
And as we have been saying, the sediment isn't devoid of life either. It's just different. There are a lot of animals that find their home in the sediment for both protection and food. We talk about the infauna, so it's those that live in around the top 10 centimeters or so of the sediment surface of the seafloor. And it's actually a very diverse and dynamic environment, and especially here where I think we're seeing a lot more organic matter in the water. The infauna is probably really dynamic in this location. So even though we can't see them, they're in the sediment. So both the macro and the microfauna all over this seamount.
Yeah, absolutely, Jason. And those forms are much smaller because they live actually in the sediment, so they make holes or burrows and can burrow themselves in. And some of them actually can be, relatively large. We see sea stars and urchins sometimes that can burrow themselves all the way into the sediment. And then we see some smaller organisms as well, so smaller worms and little crustaceans, much more of the micro.
I will let it go.
Beautiful. These beautiful Metallogorgia leaning over with the current. And some sediment waves here, Jason.
Coming partial.
I was just about to write that in the chat. So we were definitely seeing a relatively thick sediment accumulation, especially if you've been with us on other dives. Seeing these ripples points to a strong, rather persistent current through this region.
Hold that.
I think we can kind of see that with, how some of the corals and sponges and crinoids and other things are kind of blowing around. The dead skeleton on the bottom there.
Actually, just looking at the top of this Metallogorgia, and I've just noted that this one doesn't have a brittle star in the middle of it. And so usually when we see these Metallogorgias, they have a brittle star wrapped around. So I don't know if Scott is still on the line. Well,
no, you're right. You're absolutely right. That would be.
Unless it's hiding at the bottom somewhere.
I see one.
Yeah.
I think I see it. It's in there.
Oh, wrapped all the way in. Look at that. So well hidden. I've never seen one quite so hidden as that.
This particular colony is really thick with branches and
Do
polyps,
a pirouette.
so it's a little hard to see through it. We're just looking on the wrong angle.
Absolutely, yeah. I think it's just tucked right at the bottom end.
I don't think so.
So these Metallogorgia often have a brittle star, or usually, I should say, have a brittle star wrapped around the center. Yep, you can
Always.
just see its legs. Here we
Not
go.
always.
There you go.
There it is. I thought we were going to find an exception to the rule there, Scott, but we didn't.
Well, that was great to ask about it and look so closely, because it sort of proves the rule, doesn't it?
It does, it does. Yeah, these are definitely very thick Metallogorgia. They have a lot of polyps in their umbrella. Beautiful.
Turn back towards the direction of movement.
Did I get another move in?
I think so.
Another 15.
Yeah.
Good with that now? 225.
Just beautiful. Lots of species of deep sea coral already.
Yep, good
We've
with me.
Copy.
only landed just under an hour ago on this dive 19 of the. Yep.
Can we zoom on this side of the corallium? Oh, no, it might be already too late.
On the back side or the front side?
No, the front side with the polyps.
Bridge,
Yeah, pilot watch lead.
If we're already past it, we'll see more. So that's okay.
We would like
Les
to
Watling
request a
is
ship
noting
move.
in the chat room that we can
Range
potentially
15
identify
meters.
species if we can see
225, speed
the
decimal
presence
2.
of basically tunnels created by the coral
Okay.
under the influence of
Sounds good,
worms
thank you.
that live on the colony, and you can see that from the front side.
Yep, so they're just setting up to have a look on the inside there. In the background there's actually one of these Metallogorgias. It's one of these more
Come in
juvenile
video, yeah.
forms, so it has some of the branches coming down the stalk, which is what we were talking about a little bit earlier.
Go for the edge.
Oh,
Is this the right coral?
and yeah, this is the right coral, but
Okay.
unfortunately it was the opposite direction. That's okay, we'll see more. Thank you so much.
Okay.
Tilt down.
It's a beautiful structure of this hemicorallium. You can really see those thick branches branching out into smaller branches, and the polyps, really dense mats of polyps in this particular species. And these are octocorals, so octo 8. You can see those 8 tentacles sticking out. And again, these are clonal, so these are all genetically identical. Oh, and there's a little bit of overgrowth of a zoanthid there as well. Beautiful.
Little beauty shot.
Thank you so much, pilots.
It's interesting with, sorry, Rian, it's interesting with these hemicorallium, we
Oh, wow.
often see what you just pointed out, the zoanthid or sponge overgrowth or barnacle overgrowth and so on. And to me, that suggests that these hemicorallium can live for a very long period of time. This colony's probably been in place, multiple decades. And as some of the tissue grows, other species take advantage and grow on it, but the original colony doesn't die. So just one of those clues that we use.
I think I might see an Iridogorgia on this boulder that's coming up on the right-hand side here.
Copy. Oh, yeah.
Yeah, well, tight whirls.
Video to snap it as I approach.
Yeah, just a small one,
Just a young
but
one.
it's definitely there. I don't know if this is the smaller form of different species or whether this is a juvenile of the larger species. If anyone in the chat room has a thought on that. More of that bright purple clavularia.
You want to pay out a little bit.
Copy.
Just give it a little.
Beautiful.
Watch your altitude in your sonar, but it should be fine. You can come back in video. I got my toe down now. Co-pilot's going to give me a little more tether.
As Scott Francis confirmed, this is the smaller of the Iridogorgia, Iridogorgia splendens.
Yeah, I've heard that name before.
And I can see on the inside here, I think it's a shrimp. These often have shrimp or sometimes squat lobsters living on the inside.
Go ahead.
Hard
I
to,
think you're right the first time, Rian.
yeah, hard hard to tell, but I think that's a shrimp body I can see. Beautiful.
Yeah, it's the coloration that I'm using, and I can see the purple embryos, and I don't
Copy.
believe you would see that on the chirostylid crabs.
Beautiful.
Copy, you can go ahead. Sounds good. Pilots are going to adjust heading a couple degrees.
Okay. Next video.
That shrimp, like other members of the Pleosomata, once they release the eggs and fertilize them, they will carry those fertilized eggs, the embryos, on their pleopods, the swimming legs under the abdomen, for some period of time. And often when we see them in these Iridogorgia and Chrysogorgia, it's a female who has embryos, and so the hypothesis is that perhaps they're in there for protection from predators.
You can see a red colony of Paragorgia there in the background. That's another one to add to my ever-growing long list here for species on this dive so far. Just behind a Parantopathes, a black coral with lots of branches.
I'm going to come in on these two, though, on the right side as I center them.
Beautiful. And more of that bright
Kinda
purple
off to my left.
clavularia.
Kind of an awkward spot for me to get, but you can come in more. Just bubble gum on the black.
Would you say these currents are pretty typical of this area, or has it picked up because of the weather in the area?
So the currents in this area, so this, Retrieva Seamount sits just at the edge of the Gulf Stream. There are little eddies that come off and can affect this area. And that's one of the reasons that we're seeing, we think, so much life down at this depth where we get these high currents. These tend to be areas where we see more in the way of deep sea fauna, particularly on seamounts, where they can increase those currents. And we see these filter feeders and these and suspension feeders that need to pick particulates out of the water. So as for being typical, I could ask other scientists who are on the line who visited this area other times as well, but I would say they're relatively typical for this area.
Yeah, just from the brief look that we've seen at the
Thank you, Bridge.
At the sediment and the ripples that are developed there, it sure seems like there is a certain persistence of the currents through this region. And as just to reiterate what Rian just said, at the edge of the Gulf Stream, that
Come up just a little bit before
of the north wall of that Gulf Stream and the eddies that can come off here. I think this would be quite the norm.
It's always fascinating to think that oftentimes we get to look at rivers and see the eddies and movement in there on land, but it's one of those other things to kind of consider that underwater as well, and creating that same effect that we see in rivers that we come across in our backyard.
Yeah, absolutely, Brittany. These. Go ahead, Jason.
Certainly multiple levels of. Yeah, so there's multiple levels of current. Certainly the Gulf Stream is more of a surface current. So we see that, expressed through a lot of the remote sensing and other things that and water temperature of the ocean is a good proxy for the Gulf Stream location.
Yes.
And down here we have bottom currents, which are, have been quite persistent for thousands to millions of years. So it's really this dynamic nature of the near surface currents, and then these bottom undercurrents. And one that has been going through this area for quite some time is the deep western boundary undercurrent. And you can see that in the big accumulations of sediment around the base of these seamounts. Kind of marks the influence of those currents. So it seems that on top of this pinnacle, we're capturing a lot of different oceanographic processes as well, just by the amount of life that's here.
Yeah, this is a really beautiful view. These boulders absolutely covered in what I'm pretty sure can be considered a coral garden. So coral gardens, we use the term garden when the number of colonies gets over a certain amount per area. And just from experience, I would say that the amount of coral colonies that we're seeing in this area would constitute a coral garden. You see these sponges as well. So the corals are those suspension feeders picking out particles, and the sponges are what we call filter feeders. So they filter water through their pores. The pores have special cells called choanocytes. They have little wiggly flagella in them, and those flagella create these water currents. And so the water currents move through the sponges, and then other cells pick out all of the good stuff, all of the food and nutrients those sponges needed to grow. And so we often see corals and sponges, living in relatively similar areas. Both of them need a certain amount of current. Sometimes we see sponges in areas with slightly less current because they can create their own with those choanocytes. But both of them tend to occur on these hard bottom areas where we see a bit of water flow to help bring in the food. Just beautiful.
Video, you want to come in on the white colony here? I think they wanted to see the backside of this species earlier. See if it's...
Yeah, there we are. There's the front side of one of these hemicoralliums. And the feature that the scientists in the chat room are looking for is little worm tubes. Sometimes they can be a bit more visible towards the base. This one's really dense, so we might have to look a bit further down. And this will help identify species.
Yeah, and often, Rian, what we're looking for is more of an abnormal swelling of the branch thickness. That gives us a clue, or you can look at, if you're following polyps, like actually I think I saw one there in the lower right. As you're following the polyps around, suddenly the polyps seem to bulge upward because of the skeleton. Nice little predatory gastropod snail on the rock, and I think I see a stoloniferous octocoral also along that rock. All kinds of stuff. Once you look closely at the bottom, it's just remarkable how much is alive and living down here.
Okay, video, come back in now. Hold that.
Wow, this is beautifully dense with all the polyps. Sometimes on some of these corals you can see minor branching, and there's a lot of space in between, but these corals seem to be quite dense with all the polyps taking up as much space as possible to be able to get all of those kinds of filtering or anything in the water column to possibly consume.
Yeah, Kim, that's a particularly interesting strategy that these hemicoralliums seem to deploy. When we see these colonies, they often have very dense branching like that, and these polyps almost touching one another. And so you can imagine it's a pretty complete net that they're sticking out there in the water flow.
I want to get a 20-meter move in.
Very different, for example, from the whip-like corals that we see around here.
There
we go, like that one.
Yeah, and even these, I think they're stocked chrysogorgids. Correct me if I'm wrong, Scott?
Yeah, what do you have as uphill, Josh? That next way.
Metallogorgia. Same family, the Chrysogorgiidae, but they're in the Metallogorgia. One of the things, though, that is similar to that hemicorallium with the Metallogorgia is that once you get up into that crown of branches, then it's relatively dense. And you see the way they sort of nod over. They're catching the current, and the water is passing through them from the stalk side and then through all those branches.
Probably do 30.
There's an awful lot of polyp and tentacles that the water has to pass through, and so good chance that the good organic material for feeding on can get picked up by some of those polyps.
Bridge RVNAF.
Yeah, it's clear there.
Absolutely, and you can. This is a great shot here of what we can see as far as marine snow goes in that water column. So we refer to marine snow as that organic or detrital debris that's mixed into the water column. So this contains all the sorts of organic material that has been pushed up into the water column, as well as sediment particles that travel through the water column. And you can see that based off the covering that we have of these features here, there's a lot of sediment as well as other debris in this area, and it could be that these were deposited from the water column then itself. At least the small sediment grains were. Now I think I heard
Rian noted this earlier.
Go for it, Scott.
Sorry, I was going to say, Rian noted this earlier. You can see 3 of these Metallogorgia umbrella-like pink things on the right. And then on the left, just going out of the screen, looks like maybe a discarded house of a larvation. Just off screen to the left, you're going to see another metallogorgia, but this is at a different growth stage. And so this whip-like thing that you see that's got sets of branches coming off about halfway up and then going all the way up to the top, that's an earlier growth stage of this metallogorgia. We call it the teenager phase or the juvenile phase. And as they grow, the branches that are along the stalk will all basically drop off, and they'll only keep the branches at the very top. And this one is probably old enough that the brittle star has moved up into the crowns. It's at the far left, but you can still see it has a number of those branches along the stalk. So we're not sure exactly why and how that occurs. There's clearly some genetic physiological signal during development to stop supporting and feeding those lower branches.
For a minute while he talks about it.
Yeah, they just drop off. There's still tissue there, but there will be no branches.
I hope I'm on the right one.
Oh, thanks God. I didn't know that the branches could actually, or the tissue rather, then kind of dissipates from that center, from the more of the middle stages of that branching there. It looks like we also...
So just the branches. The tissue stays on it, and you can tell if there's no tissue on it, then there will be other organisms living on the stalk. And I should also just note that we only learned this after making a number of collections and doing some genetics and then realizing, and looking at the morphology of the polyp, realizing that these were the same colony. And there's an acanthogorgia in the background on the lower right.
Just goes to show how much we still have to learn about the deep ocean and all that inhabit it. So I think I heard Brittany Peterson on the line earlier today. So as we've stated previously at the beginning of this dive, we were actually inside the Northeast Canyons and Seamount's Marine National Monument in this area. And we've been seeing quite a few of these corals and sponges and everything there. Brittany, do you know of other things that we have seen in the monument?
Copy. Yeah, I think I'm finally starting to move.
Yeah, thanks for the question. One of the unique things about the monument and where it's located, as it's kind of been discussed, is the amount of current that flows through this area, and just happening to have these seamounts and these canyons creates such a unique opportunity to push nutrients up and serves as a feeding ground and a nursery for so many species, whether it's those small creatures like we're seeing here, whether it's corals or smaller fish, or it could be larger things such as blue whales. There have been Greenland sharks seen in the Marine Monument, and just a humongous concentration of marine mammals of all different types of diversity. It's really a oasis in the middle of the ocean for these creatures, and especially for migration as well. The U.S. Fish and Wildlife Service has a long history of managing migration corridors, in particular for migratory birds, migratory insects such as monarchs. But then when we move out to the marine monuments such as this one and the ones out in the Pacific, it creates a nice little stepping stone for these creatures that aren't bound by boundaries and saves these places for their migration, for their movement, for their feeding and reproduction. I'm really curious to see what else we find. Especially one of my favorites is always an octopus. Especially with these deep sea creatures with their big eyes and ability to live in these dark, deep places.
Great, thank you. Yeah, and as we have seen quite clearly throughout this expedition and previous expeditions, animals and these organisms, especially migrating ones, they don't have geopolitical boundaries. So they can migrate through some of these areas, and we might never know unless we just happen to be exploring at that time. But it's a great way to keep monitoring what's in this situation and what we could potentially see as we continue exploring. So thanks for that, Brittany.
Yeah, and just the beauty of this is just stunning. Most people don't get the opportunity to see that, and as it was mentioned on a previous dive, identifying corals based on skeletons, but seeing them in real life is a totally different experience and very inspiring.
Peduncle?
Absolutely, and Does that look like a rock pen to folks on the chat room?
Yeah, absolutely. I've been typing in the background madly. I wanted to make sure we got a view of this.
Thank you, Bridge.
So that is a rock pen. It's a classic.
So that last 30 meter round's done.
Anthitylum that has that curled rod that you see. Not sure why these colonies do that, but they always do. So this is interesting because it's different from the Caribbean form that doesn't have that curl. Great observation. First time that I know of that we've seen that on Retriever Seamount.
Thanks, video. Looks like I got a little more tether. Can continue on this saddle. Going up just a little bit.
Yeah, this overall feature here looks really interesting overall. As I mentioned earlier, we're seeing a lot of this kind of sediment, partially likely due to the marine snow that you can see in the water column, of all of those particles that are within the water column there. And then we have some really distinctive like boulders, for everything from sand grains to cobbles, and then these large boulder-esque features which look pretty cemented and conglomerated within this section here.
Yeah, it's a very dynamic bottom environment in terms of the material. So there is the sediment, and it's patchy, but when it is accumulating, it's pretty thick, and there does still to be a large biogenic component in that. By biogenic, it means it's coming from the water column. It's marine organisms that when they die, their shells or tests fall to the bottom and accumulate as sediment. We're seeing these larger, more pavement-like outcrops of rock that appear to be quite firmly in place. A lot of boulders that look to be eroded off these larger outcrops, although I haven't really seen any evidence of where they're coming from. Everything is still coated with ferromanganese crust, so it's kind of hard to see. But then there are the smaller cobbles and pebbles and gravels that appear to be quite mixed. And as we've been going through the dive, trying to look at a bunch of those, there's quite a range of colors, sizes, shapes. Some of the colors are not what I would expect from a seamount, and are reminiscent of somewhere else. So there's the potential that a lot of the loose material of certain sizes from the seamount is actually being deposited by processes such as ice rafting material that gets caught inside the glaciers and icebergs as it's eroding the land surface. And as it melts, once it's out in the ocean, that material drops out.
I'd like to request the ship move.
I think we're seeing quite a component of that here.
225, speed decimal 2.
And certainly we're seeing a lot of coral debris, dead skeletons, and twigs, and other things. So, really interesting dive, and quite different to the other eating dives we've done so far.
Yeah, and just in this one shot, we can see on this kind of more hard ground surface that there's so much biology, everything from corals to sponges, as well as those that utilize the corals and sponges to get up into the water column, such as the ophiuroids or brittle stars, as they're known. And right off to the left-hand side here, you can see that there's a whole bunch of coral rubble in this area, ranging in grain sizes that, it might not our eyes might not be attuned to it, but they also have a lot of benthic life within this system as well. So everything from the crinoids can stock on it. I see a few brittle stars right off the bat here. Even some potentially some other corals or things that are growing possibly on the hard substrate underneath this coral rubble section here, and it's quite interesting to see. I see some potentially fresh dead coral or like skeletal material, as well as stuff that has been coated in ferromanganese crust, so all of that darker tone fossilized coral within this area here. Ooh, Pilot, can we get a zoom in on that coral that's right at the edge of that boulder stone off to the right-hand side, right in the sediment there?
Yeah, larger fallen colony.
Yes, thank you. Oh, and it looks like we also have a red critter up in that in the upper left quadrant there.
Oh yeah. Coming video on the fallen coral.
So this looks like a fallen coral colony. I don't see any live tissue left, just kind of covered in that grayish material, schmutz, if you don't have any better words for it. It's hydroids and crinoids, and there's also a sea star on it, potentially trying to snack on whatever would have been left, potentially, of tissue on this coral.
Thanks, video.
Jason, would you call that being already lightly stained of ferromanganese crusting, or not enough time yet, do you think? Can't really tell.
Yeah, it's probably not enough time. It might simply just be some sediment has accumulated on it and darken the color a little bit. But that accumulation, the rate is 1 millimeter per million years or thereabouts. So
come out video a little bit.
We know that some of these skeletons are exposed to seawater for some time, and we end up getting quite substantial crusts forming on them. But I think that one's pretty new.
Hey, this is Chris Ma.
Hi, Chris.
Hey, Chris.
Ooh, what do we have
back? Hey, could we zoom again on that solaster that's on that coral?
Yeah, we can definitely go back to it. Looks like we have a crab here.
We'll let him go video. He looks
not sure. Shy. We also, what looks like we have live dianthus corals, these solitary corals. Yeah.
I'll get Chris back to the...
Yeah, can we go back to that coral colony?
Yeah.
Thank you. Not sure what kind of crab that was. Oh, Peter Oster says a red crab. Chase Sion, if I'm pronouncing that correctly.
Okay, come back in on the star.
All right. It looks to be in feeding position, Chris.
Yes. That's very nice. So this is something that we haven't seen yet, or at least not had a chance to really sort of take a moment to examine. This is the Sunstar solaster. If you'll notice, it actually has 7 or at least 8 arms. And these are predators. These are, well, a lot of sea stars are predators, but these have made their kind of reputation over the many years that they've been known as being predators on other echinoderms, as well as other animals. So things like sea cucumbers and even other sea stars are their quarry. And so what this one is doing, I'm not sure. I mean, it's feeding on something. You can see the tube feet, but it's possible that the other times that I've seen this sea star on Okeanos dives, it's feeding on these little brittle stars. So what I think might be happening is that it's found some food in the way of some of these brittle stars that are wrapped around, or possibly even the crinoids that are wrapped around this fallen coral, and its stomach is probably everted onto them and is slowly devouring them. And it's got its arms in play. That's actually part of the feeding behavior. There was a study in the 70s, or in the late 60s, I think, done by Mauzé and other subtitle ecologists in Washington, and they called the unusual way that some of the solaster species fed on other sea stars the 18-arm hammerlock. They gave it a wrestling name move. And so it's possible that that's doing something similar to that here. So this is one of the things about the Okeanos dives that I've always commented on as being invaluable is observing the biology and seeing what these animals do in their habitat. We have very little information on animals at this depth, and a lot of times we have specimens that are not in context. They're from trawls and such. So being able to have them actually in situ and watching them, doing what they do naturally is just worth its weight in gold or more. So thank you for stopping.
No problem. Thanks, Chris. And that's one of the great things about the NOAA Ocean Exploration. What we're able to do and utilize the tools, we're actually able to see a lot of these organisms and predatory events in situ. So we're able to actually see how all of these events occur. Oh, it looks like we came across some debris in this area.
Come up a little bit.
I'll probably just pulling your heading off a little bit.
Copy.
And there were some sponges and then some dead sponges around. Really great features overall. We're coming up on a lot of this mixed hard substrate and sedimented area. Oh, it looks like there's I think a whip coral in the back. Is that a whip coral? I'm not sure, just the texture or the spiral of it.
Yeah, so Kim, I'm not sure what you mean by whip coral. I guess by definition, any coral that isn't branching is a whip. So this is definitely a bamboo coral whip, and it does have that coiling that you note. And this is, we've talked about this a couple of times now on some of the past dives when we've seen these. There does seem to be some evidence that these are all related, so they're genetically related, which is to say that it does look like there's a species that is more prone to coiling like this than other species. But I think it's also related to the height that they achieve and getting into just the right current flow. And once they're at that current flow, you don't want to grow higher than that, and so they end up doing a spiral. It's one hypothesis. Another is that perhaps they can't support themselves just growing higher, and so you sort of grow with the flow, and by growing in that sort of corkscrew manner, you sort of channel water through the corkscrew, and the polyps are able to feed.
It's interesting. It reminds me of trees that grow along the coast, especially in hurricane-prone areas, and how they tend to be a little bit lower and a little bit more gnarly, for lack of a better scientific description. But because of those wind effects, those constant changes in the dynamic systems that they have there, they're limited in growth, but not in years.
Yeah, Brittany, I think that's a great comparison. And these corals are growing similar to the tree in that they're growing from the tip and not the base. And so the tip is really responding to the local dynamics at the time that the polyps are producing tissue and laying down that skeleton.
So I think we just kind of came up a steeper spot, and now we hit the flat spot. Kind of more of a step rather than a slope.
Yeah.
So now we're kind of to a flat spot. So probably do 30 meters to kind of get over this flat spot.
Yeah, Jason, some of these boulders and things now are looking more angular, and maybe that they are at one time broken apart or something.
Yeah,
I'm starting to notice that there is also just within this dynamic environment already that we're starting to get more angular boulders rather than smoothed over like pavement features.
Video if you want to fish.
We're going to repeat our last.
Yeah, you might have also noticed as we just over this last little bit here. Fish.
We're gonna let the fish.
We started to see some sort of cave and void formation. So there certainly is a level of the rock here that is not in place or in situ. It's come from somewhere else. We may also be seeing additional erosion and
it looks like it's just all these like
the rock itself
features.
from a variety of mechanisms.
Saddles and flat spots.
I'm convincing myself more and more that we are seeing something other than volcanic rock underneath this ferromanganese crust that essentially erases the original texture of the rock. So it's really hard to identify what is actually there just based on the video. We probably in 99% of the cases have to cut the rock open when there is this kind of level of crust accumulation. But the overall morphology of these outcrops suggests that it may be more carbonate-rich rock types. So something similar, I won't say it is, but something similar to limestone, perhaps some reflecting some reef formation, much younger in the seamount's evolution. So these seamounts are roughly at this point. We don't have strong analytical dates for this seamount, but based on what we know about ages and the linear kind of interpolation of ages, this is somewhere on the order of 110 to 120 million years old.
It's pretty old.
So there's a lot going on here. Hopefully we can learn more, find a rock that we're convinced isn't from an iceberg. We already have one that looks pretty good. We'll look for another one before we leave, but coming up on a really large outcrop here. That I'm sure, given its high, nature up in the water columns, probably covered in more corals than we can count.
It truly is incredible the age of some of these corals in here, but also I was recently reading about the Greenland shark and just the age in that shark alone, believed to live up to 500 years. There's so much left to be discovered and understood about these amazing places. Especially, I also got a comment about how good the video quality is, considering how deep the remote operating vehicle is. And it really is a tribute to technology and the development of robotics and technology and videos, and being able to transport it up to allow scientists to see this in real life and really get that close somewhat in-hand experience of seeing all this diversity and the creatures that live here.
I'm gonna turn my lasers off for me.
This is a pretty classic view of a sea fan in the family Plexauridae, genus Paramaricia, which very often have one of these snake stars in the branches. I am trying to recall the name. Is it Ophiocrius, perhaps? Someone will probably remind me in the chat room. But corals in this family, the Plexauridae, and in this genus Paramaricia, tend to be a lot more flexible. You can see how easily those branches are moving in the current. They have a protein-based skeleton with very little calcium carbonate in the skeleton, and that's what allows them to be quite flexible, more so than, for example, the bamboo corals and the hemicorallium that we're seeing, which have a lot more calcium carbonate. If we could get a look just at the rock below the colony on the left, I think there may be an aplacophorine mollusk, which is a worm-like mollusk that is a predator of these corals. Astroschema, thank you, Chris Ma, the name for that brittle star, the snake star, ophiuroid that's on the colony. And very often there's one, sometimes we'll see two. Yeah, so there's two of them here. So those two wormy-like things that you see to the right and the left of the holdfast of the colony are we're generally called aplacophorines. I think now the accepted term is selenogaster for this group, and they are specialized predators of cnidarians, especially corals. So it's interesting to see them on the rock there. I don't know that I've ever actually seen them feeding on Paramaricia, but we certainly see them feeding on other rock corals. Thank you for that.
I was thinking back to the description of one of the other corals. I believe there's one in the background where it drops its branches as it grows older, and it kind of reminds me of a white pine that we often see in the Northeast, that as it grows up, it will drop the branches on the lower side at the where they grow out, and you can somewhat tell the age of the tree by the nodes that you can at least see. Usually they grow about one node per year, so I wonder if this coral here in the background follows a similar.
Is it all right if I zoom out for a minute?
As we see on land.
Yeah, that's a really good question.
Good question, Brittany.
Go ahead, Scott.
Go ahead, Rhian.
I was saying that's a really great question, Brittany, and the answer is it's really species-specific. Some species lay down rings almost like trees, and other species have a more chaotic kind of growth. What we're finding as we learn a little bit more about growth of these deep-sea corals is that some of them grow to a certain height, so kind of get out of their juvenile phase, and then really slow down their growth or start to grow in a slightly different way once they reach reproductive size. So it's a complicated question, but we do know that they grow very, very slowly. As you said, just a few millimeters per year. And that's very, very different from corals that grow in the upper ocean. So where we go to the tropics and we see those tropical corals that we can scuba dive and snorkel around, they're growing tens of centimeters per year. And that's because they have a photosynthetic algae in their cells, a zooxanthellae. And so that photosynthetic algae is producing carbohydrates through sunlight. So it's photosynthesizing, getting lots of energy from the sun, and then giving that energy to the coral. And all of the corals that we see here in the deep ocean are very, very similar, but they don't have that zooxanthellae. They don't have that photosynthetic algae. And so they're relying entirely on the food fall, so all these particles that we're seeing today. And so where we see a lot of these particles, marine snow, as Jason was telling us earlier, that's often where we find a lot of these suspension feeders and filter feeders.
We're moving 225.
Beautiful.
Yes. Yes. Facing that way. No.
Yeah, Rhian, to follow up on that, one of the difficulties with the Metallogorgia in particular is that the stalk, the skeleton, is so narrow in diameter that there's not a lot of stuff to work with there, even when you do collect it, in terms of trying to do the geochemistry of the layers.
Yeah,
nice big urchin here.
So on the bottom here, we're going to have a look at this urchin and also at the composition of the seafloor down behind it. This urchin, I think, is potentially a hygrosoma. I'd love to be corrected on that by our scientific chat room. So if you hear us mention the scientific chat room, it's because we're not here alone. We are using telepresence for this research cruise. So that telepresence brings you the video to you at home, but also brings it to scientists from across the world. And so scientists who've registered to help us with this cruise are in the background here. We have, actually quite a lot today, 30 or so scientists from around the globe helping us to identify species on the seafloor and identify geological features as well. Beautiful. Yeah, so this is a little bit different of a kind of urchin than we were seeing earlier. We saw those urchins that were very rounded and had very, very long, sharp spines. And these ones are kind of more flattened. They have shorter spines. And then the spines on the base, the spines that help them to move, have these specialized little boots on them. You can just see them, these little boots on the bottom of the spines. They're white in this particular one. Beautiful. Oh, and there's a tiny little Paramurcia recruit on a rock right in front of it. And we see lots of these xenophyophores, these single-celled organisms. You can see these little humps, these little mounds of what look like sediment. Those are actually single-celled organisms called xenophyophores that have built kind of a mud home to be able to protect them, and they bring in particles of sediment to make those homes.
Is that all you need, Washley?
Yes, thank you, pilot.
Got that.
And then the bottom here, Jason, looked a little bit more consolidated. It's still looser, but not quite as loose as what we were seeing earlier.
So, yeah, 225
dead
ahead.
I was about to say, it looked like one of these, almost like old pavements that you might see on some streets. Almost like the smaller pebbles and gravels there had been packed down so hard. That they were almost just embedded in the sediment and then cemented. I think they're probably loose, but it's likely pointing to that higher current that we're seeing here that kind of sweeps the top clean of sediment accumulation, and sediment can really only accumulate in those small gaps between the gravels and that's why we see this here. We're not seeing any of those larger boulders and cobbles and things that we were just seeing. I'm sure we'll see them again, but it does look like a swept sediment plain with a gravel surface.
Yeah, interesting. So here's a sea pen. And anyone who tuned into our last dive on Gosnold, a very brief dive to quite a deep depth, we got very excited about sea pens and rock pens. And so sea pens have an anchor that goes into the sediment, and those rock pens are living up on top of a rock and actually have like a suction cup on the bottom. And this one is a sea pen. And these are, again, a type of coral. They're a colonal coral. And they have other organisms that like to live around them. Here we can see some little mysids, I think, living in the branches here. And you can see those really distinctive 8 tentacles of a pennatulid. So beautiful. So there's 8 tentacles with all those little pinnules on them. Just beautiful. Thank you so much, pilot. That's great.
Good copy. Video when ready.
Can down my rotator a little bit. I have you at 60.
Copy that.
I think I'm still sliding forward a little bit from that move.
Good copy. That's a forward way.
And we can see lots of these little mounds of sediment that we realize are actually xenophyophores, these single-celled organisms that build these kind of mud homes, almost look like half a tennis ball on the seafloor. Beautiful. There's certainly a lot of them here. And if you've just tuned in to us today, I'd like to say welcome to Dive 19 of the NOAA Ocean Exploration Expedition, North Atlantic Stepping Stones. And the stepping stone that we're looking at today is Retriever Seamount. And we're fortunate enough today to be diving at in the Northeast Canyons and Seamounts Marine National Monument, which is very close to the coastline of the U.S., right off of Cape Cod. And if we still have Brittany on the line, it'd be great to have a few words about what this monument is and why it's here around these seamounts.
Yeah, thank you. Yeah, this is Brittany Peterson. I am the superintendent of the Northeast Canyons and Seamounts Marine National Monument, and I work for the U.S. Fish and Wildlife Service. We co-manage this monument with NOAA, and it was set aside in 2016 by President Obama to save this amazing place. If you look earlier in the dive, you'll see the biodiversity and the marine snow, as was mentioned earlier, that is full of nutrients that help feed this biodiversity and keeps this place lush and productive as it is. And marine monuments, honestly, are just a newer concept for the U.S. Fish and Wildlife, or for the U.S. Fish and Wildlife Service, but also for the U.S. in general. The first one was made by President George W. Bush, and that was the Papahanaumokuakea Marine National Monument out in the northwest Hawaiian Islands. And so over time there's been more added, but this is definitely the first one in the Atlantic. Often we don't know about these places right off our shore, especially if they're deeper, because somewhat technology has not been able to catch up. So through the work from Dr. Oster and other researchers, we've been able to identify this place as a living
Yes, I do.
organism in a lot of ways. There's so many other organisms embedded in it, and just a source for so much migration, whether it's highly migratory fish or even those little critters that still make it through our oceans and move from place to place. It really is just an incredible place, a mixture of currents, geology, and then just a variety of species that rely on this place for their migration. And as the name of the exploration says, stepping stones from one place to another.
Yeah, thank you so much, Brittany. And we feel very fortunate to be able to dive in today because, of course, we were blown out by weather. We were supposed to be here yesterday. So this is an interesting sea pen here. It's a little bit different from one that we've seen so far. You can see its polyps are all kind of on one face here, this pennatulid. I don't know if we can zoom down to the base, Pilot. That would be great.
Yeah, of course. Going to base.
Yeah, kind of tucked in the sediment there. Yeah, so it's two different kinds of sea pens that we've seen. And apparently while I was at lunch there was a rock pen that went by as well. So these sea pens are a type of coral, a pennatulid, and they have, many of them have an anchor at the bottom. So that anchor will go into the sediment. You can kind of see the base just disappears here into the sediment. And that anchor can sometimes be really long, up to half a meter or so below the surface. Beautiful. Thank you so much, Pilot. I think just behind it to the left, a little bit behind it to the left, I should say, not right behind it. I think there was a cup coral on the surface there as well. You can just see the surface here covered in these ophiroids, these brittle stars. You see them all draped all over the rocks.
Is it on screen, Watchlight?
Nope, I think if we keep going, it's very kind of yellowy white and round. There you go.
Up there?
Yeah, it just popped into view. Yeah. So I think here we're seeing another cup coral, a solitary cup coral. This one is not a desmophyllum. Sometimes it can be very hard to identify these species of cup coral on the seafloor. They are traditionally identified by looking at their skeleton, and very often species of deep sea scleractinian have actually never been really visualized alive and on the bottom before. This one has a very rounded shape, suggests maybe it's in the Charaphyllidae.
Our video will come on out.
Yeah, this one's very rounded and sitting on the base on the rocks here. Now it kind of looks like this cup coral is sitting in the sediment, but I would wager a bet there's actually a little tiny pebble, one of these small rocks that we're seeing in the foreground underneath, and that's where the larvae have settled and grow. This is probably a Caryophylla, I would say, maybe a Caryophylla ambrosia. Beautiful. Very nice. Thank you so much, Pilot.
Copy that.
And you can really see as we zoom in here that the bottom is very far from lifeless. You can see all of those brittle stars as well as worm tubes. There's a lot of small organisms that live on these habitats. And as we've seen through the expedition, where we're seeing kind of looser material like this, where it's looser pieces of rock, we don't tend to get really big forms, so we don't get those really big branching corals. But we do see a lot of smaller forms, so a lot of smaller organisms living in that. And the reason we think is because the rocks are a little bit mobile, and so to be able to grow into one of these big corals, it takes a very, very long time. Yeah. They're growing just a few millimeters per year.
Right. Got it. You're ready.
But they also are just a bit too heavy, so if they grow too much, they'll lean over, the rock will tip, and then they won't be able to grow anymore. So we tend to see smaller forms. I'm seeing a few of those cup corals here as well. I think there's one's just on the lasers there.
The move range 30 meters.
Beautiful.
Bearing 225 degrees, speed 0.2 knots. Good copy. Thank you.
Again, fields
For
of these.
my terrestrial folks.
Oh, go ahead, Brittany.
I was just looking at the Cajun habitat, but for my terrestrial folks, would this be analogous to kind of where we saw the corals growing tall and almost forest-like, or as you put it earlier, gardens, and then moving into more of like a grassland and an open area in like a earlier stage of habitat? Well, obviously this is older, but where it might have more influences as far as the dynamic system that could reduce the need for, or reduce the capacity for carrying those larger corals. Would you say that would be analogous to a land example, or?
Yeah, I think so, Brittany. I think that's a really good analogy there. You know, one of the joys of doing exploration dives for me is crossing into these different transition zones, because sometimes when we only have a quick look at a seamount, say one dive or two dives, to truly get an idea of what organisms live there, you want to cross into these different transition zones, so cross into these different areas that show a different geology, a different morphology, because different kinds of animals live there. And so if you want a good idea of what lives on a seamount, you have to go into these different areas to find out. And so here we've crossed even into another one again. So before we were seeing quite dense aggregations of these small little pebbles, and now we seem to be in a very, very swept sediment environment with some of these larger rocks here.
Yeah, you know, that was a very rapid transition out of that gravel mantled top to this now seafloor, to this now sediment sort of dominated environment. We're still seeing the xenophyre forests, and we're still seeing some gravel here, but you can almost see, you know, in this sediment, these lines going, you know, up and down the slope, likely pointing towards the current influence on the distribution of the material. Likely a very much more mobile bottom. So, you know, while we see one or two corals, I think that's a yellow one there. My video is dropping out, but the transition was quite abrupt in terms of, you know, what we do see on the bottom. So, it points to a different process, oceanographic and geologic processes, the physical processes that shape the bottom. You know, as we move back, you can see very quickly we go back into this gravel mantle top. So, you know, one of the interesting things we look at is to see how wide these bands of different bottom types are, and whether they represent smaller scale processes or some bigger fundamental change in the bottom type, or the processes, or the accumulation of sediment, different currents and things. So, you know, a lot to be sort of interpreted just from, you know, looking at the bottom.
Definitely, Jason. There's a lot of really good scientific information that we get out of just having a look and seeing what's there. And certainly it's been very interesting. You know, we started this dive a little bit deeper along our track here, and it was these large boulders where we saw really a diverse, almost coral garden community with lots of sponges and associated fauna. Then we moved into more of these kind of pebble-like area, and then into these sediments. And it's really amazing how we can cross over into this different zones, and we're kind of moving back and forward along them here as we move upslope along our dive track.
Some maybe
Yeah, it's
Small
coming up.
returns
I
coming
think
up.
I was thinking that was D2 for a bit, but I think that might be a return as well.
I think that's a fake.
Oh,
I think that's, I've been watching it for a while.
check that.
I don't think it's real.
We can still see in these sediments some of those xenophyophores, those single cellular organisms that build these almost tennis ball-like houses, and some sea pens here. But I would say the diversity has really dropped off in this particular area. There's a lot more of that sediment. And so what I suspect is happening is we're seeing a lot more of those smaller organisms, that in fauna, living in the sediment rather than on top. The top is just too unstable to house a lot of these larger organisms.
Thank you, Bridge.
Watch it go. Yep, of course. All right, Biddy, you want to start to come in?
So this looks like a Paramaricia, a smaller one, and you can see that although it's in this field of sediment, the larvae has managed to settle on this larger rock here. You can see the base of this coral that's grown on this larger rock and has grown up from there and has its snake star, brittle star associate in the middle of its colony there. Thank you so much, Pilot. That's great.
Copy that. All right, video. You're set. Get lasers on it real quick. These lasers looks good. All right, we'll keep going.
Looks like there's a large white coral colony up to your upper port. As you turn, you'll be able to see it in Sirius. But that'll probably be on those rocks that we're seeing out here, like 15 meters away.
Oh
See it there?
yeah, that's too far, unfortunately.
Oh, is it larger coral colony here? Interesting. I suspect what we'll see at the base of this one is there'll be a large boulder underneath.
It's out of our range, but if you want to snap from here.
It's just out of range, but I think I can see that larger boulder underneath. Oh, look at that bamboo skeleton. So these bamboo corals have skeletons that look like pieces of bamboo, and this is a beautiful example of that, where you have the white calcium carbonate and then these black proteinaceous nodes.
All right, Biddy, when you're good, come on.
Beautiful.
Thanks.
And I can just see some rock in the distance there, suggesting maybe we're coming up to a more rocky area again.
Yeah, watch it. It does appear that on the radar, probably another 20 meters. And
oh yeah, perfect.
Transition.
Yeah, so if you want to switch to your live streams number 3, you can see in the bottom right-hand corner there's a bottom box. It's called the Blue View, and this is a forward-looking sonar. And so this helps to give the pilots an idea of what's coming up, and is a really great tool for us scientists as well to have a look and see what the broader overview looks like in the area. You can see we're coming up on kind of a rougher area there, a rougher texture in the seafloor.
Watch it go. Understood. I'll keep my eyes open.
You can see a lot of the larger rocks in this area all have something growing on them. And that's, you get a supply of larvae into an area, and they like to settle out on these larger rock pieces. Like this one here, I think this is a sponge. Yep, little type of sponge.
Video come on.
Very small, with a brittle star hanging over the edge.
Video wide, please.
Oh.
Thanks.
And again, you can really see those marks kind of coming towards the camera right now, and so that's the current as it kind of scours and takes some of that sediment downhill.
Yeah, I must admit I didn't expect to see a sort of an open plain of this type near the top, and perhaps we're between two pinnacles or just on one side of a pinnacle that is getting
there's those rocks there.
Sort of enhanced flow, current flow that kind of sweeps it clean.
Slope looks similar.
And almost as I say that, we kind of float back on into starting to see more of these larger boulders and perhaps in situ outcrops that.
So this section I can't quite.
Providing a more solid basis for these benthic fauna to attach to and grow. So it's
coming back down.
We only get such a small view with the ROV and the cameras along our little track that we go up.
It ended 6 minutes ago.
Good copy.
We try to interpret as much as we can, and then later on, hopefully we'll be able to extrapolate those observations to get a better sense of the overall distribution of the bottom type on these seamounts. So really is informative to we see things from the ships and remote sensing and the maps that folks like the mapping team on the Okeanos Explorer are producing, but getting down here and actually seeing them with our own eyes is really important to help us interpret what we do see from those maps and other data.
20 meters out, looks like. It's always right.
Yep.
Yeah, there's a lot of more recent skeletons in kind of the sedimented patch here, and you could see some of these larger Iridogorgia skeletons that were laying on the sediment a little bit back, as well as lots of pieces. So again, when we've seen that before in our previous dives, it suggests that there are quite large coral communities up above where we are right now.
Should be just about close to stopping.
Here we seem to have
start thinking about another move.
reached an area of more rocky bottom.
I just want to take a quick peek
around this area.
Sure there's no sample items and keep going.
Copy that.
Past what, Rushley? Yeah, understood.
And you can just see the contrast between these sedimented areas and then moving into these harder rock faces, these harder rock bottoms. So most species of coral really prefer to live in areas that are rocky. Their larvae settle and grow in these areas. There are a few species that can settle in kind of more sandy and muddy areas, but they still tend to live and grow initially on a small pebble. Very often you'll find a small little pebble at the base, even of species that tend to live in more sedimented areas.
Maybe like 15.
I agree.
The next one.
We can see on these rock faces there's kind of almost like a purpley white color. Those are encrusting sponges. And we see more of this Paramaricia, a couple of other kinds of sponges here as well. Bright yellow encrusting sponge there in the background.
You got some coral on your starboard side that you're going over.
And it looks here, Jason, like the sediment is a lot finer grain. Like it doesn't look the same as what we were just looking at.
Is it a long whip?
Yeah, a large red.
Yeah, I don't know. I think you're right, and it's certainly a process of winnowing or separating the different grain sizes as it is transported around these larger rocks and other impediments. They act like riffles that as the sediments are once they're deposited, they fall down to the water column as marine snow, and the currents are moving them around, and generally the direction of movement is is down, as most things under the influence of gravity tend to move down as far as they can, and that's the abyssal plain ultimately for this seamount and the sediments on it. So, as they move down in certain places like this more rocky outcrop, the sediments get somewhat sorted, and so we see those more on those more open slopes where there aren't as many large impediments to the flow. It's certainly you get the more coarse sediments mixed in with the finer, but here we're kind of winnowing parts of it out and accumulating finer patches, and we probably see coarser patches and finer patches, and it alternates back and forth depending on the nature of the flow and the availability of sediment. So,
Copy that.
Pilot watch lead.
Watch it go.
Can we zoom in on the, it's right on the bottom, on the right-hand side. There's like a brambly bush there. I don't think we've had a record of that one just yet. If you could have a quick snap zoom, that would be great.
Okay, copy that.
Irene, I think this is going to be what we would call an isidella right now, bamboo coral on your right. We haven't seen this.
Yeah, definitely that more bramble form, and you can really see why it's called a bramble form when you look at it. And it's got, looks like an Okeanos growing through the middle of it.
Yep, I would predict this has nodal branching.
I don't know if we can zoom in a little further. Let's see if we can find a node. So the nodes are these black or slightly dark brown areas that give the bamboo coral its name. And I can see, oh, yep, nodal branching. There we are.
Yep, great. Okay.
Yep, perfect. Thank you so much, pilot.
Good copy. Video when you're good, come on.
Pilot watch lead.
Watch it go.
So we've had a request for a angular rock. I think there's almost one that would be dead on the lasers if that one is loose.
Yeah, right there.
Right there. If not, there are some in the very top right left-hand quadrant as well that would be contenders. Something nice and angular.
Understood.
Thank you.
Good spot, Copilot.
Yeah, I'm stationary.
Copy that.
So as predicted at the beginning of this dive, when we sat down and saw so many different species of coral, I'm already running out of room on my paper here where I keep note of all the species that we take during a dive. This has certainly been a very, very abundant area for deep sea corals and sponges as well and other organisms.
Yeah, where were the samples? Is it just one in the...
There's one in the port forward.
Okay, and that's the only sample we've taken so far?
Correct.
Copy that.
And so this is a good time to state that any samples that are taken during a NOAA ocean exploration expedition go to national repositories. So these are not collected for any one person. They go to a national repository where scientists from around the world are able to take out these samples and do studies on them. And so they're an incredibly valuable resource for truly understanding some of these very remote and newly explored seamount areas.
That looks pretty stable there.
Copy that. I'll switch my monitor if you're ready.
Yeah, go for it.
Alright, you're ramped up. I'm looking at your arm, ready to follow you out as you come live.
Alright. Arm's coming on, 3, 2, 1. Arm is on.
Copy that. I'll follow you to the center.
Mixing out. Ooh, that is stuck, actually.
Oh, that one is solid. All right. Well, thanks so much for giving it a poke. Maybe we can try some of the others in that top left area.
Yeah, understood. There's nothing in view, right?
I don't see anything else in view here, unfortunately.
Yeah, copy that.
But I think in that top left there were several contenders, so that'll give us a few different ones to poke around.
Do you want Sirius
Thank
back
you.
for that move?
Sure. So top left, is that right, Watcher?
Yeah, I feel like in that top left, yeah, very top left of screen right now, there's 1, 2, 3 potentials right there. I don't know if they're too big, I guess.
Yeah, we get closer and see.
Is there such a thing as too big?
I think the pilots may think there's such a thing as too big.
I think the three biggest ones there look a little too large.
A little too large? Okay.
Is there anything else on screen that's of interest?
Nothing in screen, but actually back to the right there was almost like a collapse feature that might have had some in the bottom here. Emily, with her good eyes, had noted some.
Yeah, backing out.
Yeah, just under this edge that's coming into view now. I don't know if they're maybe too far under.
That, I think, yeah.
Okay.
It's a little too low and back for the arm to get in there.
Okay, in that case, it's just keep our eyes open as we scan around here.
Understood.
Thank you.
There may be some
It's an
more over to your
interesting
port,
feature, though.
so you continue to
Quite
come around.
deep, back into the outcrop. It's either been undercut or some other collapse process that
we were both touching
generated such a deep cave in an area that we haven't actually seen much in the way of caves. So wondering what ultimately what the process was that generated that. We saw a lot of those in the earlier Seamount dives where we had the volcanic, the pillow, low bait flow morphologies that crust forms on the outside of the pillow and the inside either doesn't get completely filled or it drains out.
Yeah, try 235.
Over time,
Copy, I'll come over.
things get weak and that crust breaks. And you can form these little cave areas, but that was one of the more interesting ones we've seen lately.
Yeah.
Yeah, that really did look like a different, you say we've seen lots of those kind of collapsed pillow features, but that one was just a really deep little cave in there. It was really intriguing.
What do you think about that?
Yeah. Sorry, I overshot a little. That looks good to me. 235.
On this rock face here, we can see several colonies of Okeanos.
Yes.
We can see Bathopathes. A little bamboo coral poking up from the bottom. Again, lots and lots of species that we've seen so far in this dive.
I'd like to request to move range 10
Scott France noting that this is obviously a good place for that Okeanos. We've seen a lot of those from the very beginning of this dive all the way along so far. Same for these Metallogorgia. We've seen a lot of these Metallogorgia, these ones that look like little umbrellas with the bright pink tops and these long stems. Pilot watch lead.
Hey, watch lead, go.
Could we zoom in? Bottom right-hand corner, there's like a pink skeleton sticking up right next to an orange bottle brush. Yep, pretty much on the lasers now.
On lasers now, copy that.
Oh, and then I don't know if the rock to the left might be loose. That'd be worth taking a look at.
Yeah, copy.
Thank you.
Cancel that move.
Copy that.
Thanks.
Bridge ROV nav. Could we come to an easy stop, please? Thank you.
All right, video, you want to come on in? Is this what you were looking at, Watcher?
Yeah, just above, I think it's a bamboo coral. Yeah, this one in the front is absolutely loaded. This is an Okeanos, absolutely loaded with these crinoids, and in the back there's a bamboo. And actually, back right-hand corner, you can see one of these solitary hydroids right next to an Okeanos. Beautiful. Solitary hydroid just poking into view.
Is that what you needed, actually?
Yep. Just to the right would be good if we can. Yep. There we go. And this is a great view of both the solitary hydroid. It's kind of looking at us with its tentacles out. The hydroids are a type of cnidarian, so they're related to the corals that we're seeing. We can also see at the base of this Okeanos, this bottlebrush coral, those roots. And Scott France was telling us earlier in this expedition that this particular species grows these long roots, and they can be kind of dripping, look a bit like wax drippings.
It just disappears.
And they can be on rock or in sediments. Really beautiful.
Towards the sounds good.
Sounds
That's
like
great.
a good
Thank
plan.
you so much, Pilot.
Thank you.
Is that all you needed, actually?
That's great. Perfect.
And then rock.
Yeah, rock over to the left. Or several, I guess. There's a few choices there.
Is the one... I'll center it up real quick. Is that the one you were...
Yep, that's the one that caught my eye anyway.
Yeah,
What a great view. Absolutely stunning. So hemicorallium, big white colony on the left, with one of these umbrella-like metallogorgia also on the left, and then just dotted all over the rocks. So these Okeanos, these bamboo corals that are little like bottle brushes. Absolutely beautiful.
And I can't help but noting there's yet another species of bamboo coral in front of the Okeanos bamboo on the right there, the one that looks like it has 3 branches coming from the base.
Yeah, that one we just zooming in on. Yep, a different species of bamboo there. Beautiful.
Copilot, in a good position?
Yes, and ship's stationary. We stopped that last move, or Nav did.
We stopped the last move, and the heading change should be complete now.
Got that.
Yeah.
I'll pull up
So
your
the
other.
pilots are just going to reach out and test and see whether this rock is loose.
Bridge.
The last rock we tried to collect was still very firmly attached to the substrate.
All right. Arms to the left, 3, 2, 1. Arm is on.
I'll follow you as you come to center.
Ooh. That one is also stuck watching.
Is it really?
Give it another go.
Oh, I was so hopeful for that one. Nope,
Yeah.
that's not going anywhere. All right.
Nothing else in reach that I see right now.
Yeah, I don't think so. Thank you so much, pilot.
Yep.
There's a couple in the upper left-hand corner of the mini Zeus right now that we might be able to move and reach into.
Maybe,
Oops, sorry.
Alright, arm is off. Get that.
Green, if we're still in place and haven't moved, if I'm not delayed, can we get a look at
Yeah,
the
you
edge
got
of
a
the rock
couple
on the lower
there,
right?
on the left.
I said,
It's a little bit up
in
from
the
you.
chat, I thought I
Can't
kept
really
version
set-
of it. Now I
there's a
don't
lot
think
of
so.
Oh, yeah.
to
Yeah.
set
And I want
down,
to see if
something
it's
like
URL out.
that. A lot of nice looking items.
Pilot, watch lead.
Hey, watch it go.
Can we zoom in bottom right corner? There's a colony of coral sitting on top of the rock.
Yes, the one in view.
Yep, the one in view. That'd be great. Just to get an ID.
Yep.
Thank you.
Is this the one we just looked at?
We did a little bit, yeah.
Copy.
Mainly zoomed on the one behind.
Yep.
There are some video issues back on shore, so.
Yeah, understood.
Yeah.
All right, video, you want to come on in? Lasers
Yeah, I
turn on.
apologize if we've looked at this already and we didn't get it.
Oh, we can see a beautiful polychaete worm right in the center of this colony here.
Huh. Okay, yeah, fooled me. It's just, not just, but it's another Okeanella.
It is.
It's quite different in morphology from the others, and their color is slightly different. Thank you for that.
Thank you, pilot. That's great.
Copy that.
Yeah, so this is one of those bottlebrush Okeanellas, and it looks like it's leaning. Maybe it's just the angle that we're looking at makes it look a bit bushier than it truly is. It's just kind of leant over.
The current's picked up just a little bit. It's 2.3 right now.
Good copy. Thanks for keeping a track on that.
You want to get that move back
Oh,
in?
another Iridogorgia is just coming into view at the very top of the screen.
Start, yes, 10 meters again. Thanks, Nav.
That's an interesting Iridogorgia. Can we zoom in on the coral? It's coming up on slightly left of center now.
Yeah,
it's kind of sticking up. Looks like it has a lot of other organisms in its branches around the edges there.
That one right there.
Yep, that one right there. Thank you. Yeah, I think they're crinoids. It's funny, these Iridogorgia, you don't often see a lot of organisms using the Iridogorgia as an associate, but these are absolutely covered.
Video, you want to come on in?
We passed over something like this before, and somebody here asked me, what's that colony? I said, I can't tell because there are so many crinoids on it, I can't see what's underneath it.
Absolutely. This is covered in crinoids. There's brittle stars in there as well.
It's a very interesting observation because I don't recall seeing so much epifauna on an Iridogorgia. We often see, like here, you can see there's a little charystylid crab in there. We see some shrimp and some mysids, but boy, I'm sure not used to seeing crinoids decorated like this.
You know, and a lot like this as well. I mean, this is just a huge number sitting on this Iridogorgia.
Video, it's just kind of blown around.
And these, you know, these crinoids like to be up in the water column as well, so they're also pick particulates out of the water to feed and to eat, and so we often see them up high, so they'll be on the tops of sponges or some other corals. We just don't usually see it on this particular species of coral, which is a really interesting find. Thank you, pilot. That's great.
Yep, copy that.
It's almost weighing down this this Iridogorgia.
Yeah, other than that, Rian, it's interesting. It didn't seem to be impacting the polyps. I didn't notice any tissue missing or anything like that.
Yeah, it seemed quite happy. All the polyps were out. Yeah, and here's another mass of these crinoids on the end of a long bamboo, one of your forked bamboos. Yeah.
Yeah, sounds good.
There must be some kind of
Bridge
crinoid
ROV
convention
nav.
in town that we didn't know about.
Yeah.
I'd like to request a move.
I don't think we were
range
invited.
10 meters, bearing 235 degrees, speed decimal 2
This
knots.
looks like another one of these forked bamboo corals. It's a whip, but it does look like it has a forking branch
Good copy,
at the
thank
end,
you.
so that's kind of interesting. And earlier on, we passed one I saw in the distance where one of those two forked tips had another branch, and that is really fascinating. That's the kind of repeated data that we're looking for that would tell us, oh no, you know, this forking is just a normal thing, and it's just, you know, a lot like these Metallogorgia we've been seeing, where we've acknowledged that there's a different growth stage, and so they're hard to recognize until you know what you're looking for, that it's the same colony at one stage and another, and so too would be the case for these whips that can branch much later in life after they get to a certain height.
Oh, here might be some loose rocks, pilot. Kind of in this little sediment chute here. This is often where we've been finding rocks that might have traveled not too far a distance. But are in
center, watch it.
Yeah, kind of in the center there. Might 2 or 3 different choices there.
Easy stop.
Thank you.
Bridge ROV
I was
nav.
confident that everything was loose, but
Could we come to an easy stop, please?
but I have a good feeling here. I'm not going to
Thank you,
give up
Bridge.
yet.
No,
One of
definitely,
these has to be loose.
definitely don't give up, Jason. So Cindy Van Dover in the scientific chat room has put out an interesting idea that maybe this is a seasonal aggregation of crinoids for reproduction.
Thank you,
And
Bridge.
that's certainly something that we see in other echinoderms. These crinoids are echinoderms, so related to sea urchins and sea cucumbers. And in certain areas of the world, we do see mass aggregations of deep-sea sea cucumbers come together for reproduction. And so it does make you wonder, because there are definitely a lot of crinoids that have been observed so far on this track.
Ramp your monitor. You're ramped up. We'll come down to get your
arms coming live. 3, 2, 1.
Copy that.
Arm is on.
Follow you to center.
Oh, we have a loose one.
Do you want to keep poking, or is that a good one?
What do you think, Jason? Is that one a good one?
Do you think the one under the left laser is too big?
Yep. Pilot, could we try the one under the left laser?
Of course.
Thank you. Of course, the bigger one. I mean, we could have guessed that.
Well.
Oh, that one doesn't look quite so loose.
That one is stuck.
Nope, that one is in place, Jason.
Do you want to keep poking, or go with the
All
first
right,
one?
we'll take the original one.
What about the one that's actually just above the lasers? Is that still in reach? It's kind of got a rounded top there.
That one is also
Also in
stuck.
place. All right, let's grab the loose one then. Thank you.
And then I'm going to have to go on the starboard side.
Yes, I believe. If not, if you can confirm.
Starboard.
Good copy.
Very nice.
Do you want to wing inboard for me?
Yep, starboard's coming in. Okay, starboard's all the way in.
Great collection. Thank you so much, pilots.
Looks like you're clear.
Thank you very much.
Starboard's coming back outboard.
Alright, arm is off.
Copy that.
Thank you, co-pilot.
Good collection. Setting up mini Zeus back. Looking forward.
Alright, watch it. Anything else before we take off?
No, I think that's good. Thank you so much.
Copy that.
Okay, switching cameras.
Good copy.
Looking down at your 3-6.
Copy that. I'll push forward a little bit.
Now, would you like to get that move going?
So if you're just joining us here today, I'd like to say welcome to Dive 19 of the NOAA Ocean Exploration Expedition North Atlantic Stepping Stones. And we're on the final seamount of this expedition. Our stepping stone today is Retriever Seamount. And we're fortunate enough today to be diving in the New England Canyons and Seamounts Marine and National Monument. Our current depth right now is at 1,891 meters, and we hope to make our way up to 1,820 meters today. And it's just been such a fabulous dive so far for deep sea corals.
It might be fake too.
We've been in an area of very high diversity and high abundance ever since we landed this morning. Just beautiful. And really amazing to see all of these different species all living together on these hard bottom area on these rocks.
Let me adjust my head a little bit, if you don't mind.
Yeah,
it's gonna come to port. I wonder if that's our, yeah. I think that's the anomaly.
Yeah?
Yeah.
Okay.
Yeah, because I had brought my head to starboard quite a bit, and it was over here. I bet we'll see it right about there now.
Okay, understood.
Yeah.
That heading actually looks pretty good. What is that, 210?
210. Is that what you're...
Oh, no, let's see.
215?
I'm looking 215.
Copy that.
That seems like a good one for the next move.
10 meters?
Yes.
Yeah, I think it sounds good.
At 215?
That's correct.
So these seamounts are well known as areas to be good for deep sea corals and sponges to live and grow. These seamounts actually interrupt the flow of deep cold water. So those deep cold currents that are full of nutrients flow along the bottom, hit these seamounts and are actually wound up. So they're sent to the surface and wind their way around these seamounts, bringing all these nutrients really high up into the water column, sometimes to the surface. And when those extra nutrients are brought to the surface, that creates a lot of phytoplankton blooms, and organisms that like those nutrients really bloom on the surface, and eventually those die and fall down back to the seamount again as marine snow, and that's a lot of the particles that you're seeing today in the water column. And those particles are what these deep sea corals and sponges live off. They need that for food. They don't have other forms of food to help them grow.
Look to the west real quick.
Lots of these really tall, long bamboo corals. We saw a bunch over the left, and there's a bunch over here on the right-hand side as well.
It's going to bland over there.
I agree. However, that is the area that those cup corals were in. I believe they were looking for.
Yeah, I can't say I've seen any since we got in this terrain.
Pilot watch lead.
Hey, watch it.
Yeah, can we have a little zoom in on this boulder as we go by, just a snap zoom?
Yeah, the one we just passed?
Yeah, a lot of different species here. I think there's a paragorgia with a zooanthid growing over it. A lot of different species.
All right, video, you want to start to come in?
Oh, beautiful. Can we actually zoom in? Can we get any further on the white and the yellow colonies there?
Yeah, on the left.
Yeah, I think the yellow is in Acanthogorgia, but the white, I'm not sure. That might be a sponge. Oh, Tina for getting in the view there. Yeah, so this white, almost coral-looking colony here, this is actually a sponge, probably a hexactinellid. It's growing on the surface here. These sponges can have very different forms. Actually, if we pan a little bit left, you can see another form of a sponge here. And this is what I like to call a hedgehog form. It's polymastia. And then we can see encrusting sponges too all over the wall. So sponges come in a great variety of different forms, very similar to the corals, where we sometimes see long whips and then sometimes see short little stout colonies. Beautiful. And we can see these long strings that are going up and down. Those are stoloniferous octocorals. Beautiful.
Yeah, I'm just kind of floating, looking. Is there anything specific, or do you just want a quick one?
No, I think we're good, actually.
Okay.
Thank you.
Yep.
It was great to have a little close up and look at some of the organisms that were a little bit smaller. It's very easy for your eye to catch a lot of these big colonies of corals and sponges. But sometimes it's nice to have a bit of a zoom in and take a look at those smaller fauna that we might not catch otherwise. The cameras on the D2 system are really fantastic. They give us a really great view of fine-scale organisms that are here. Just an amazing view here, just beautiful. Actually get a snap zoom on this bamboo here on the left.
Yeah, the long.
Yeah, long one. See what's growing, kind of that middle area. Sorry, Jason, go ahead.
No, just, making a comment on, this bottom change in these transitions. And not that long ago, we were talking about the transition from a gravel mantled sediment to sediment that had some gravel on it to, now we're moved into this very high relief area that has a lot of debris, these chutes that are carrying the sediment, gravel down slope, and lots of rock outcrop. So, now we're seeing these, larger benthic, colonies, growing and thriving. So the bottom is changing really rapidly, within meters, not even tens of meters.
Yeah, video, come on. I can set up.
And we just get to see so much.
So, Rian, yeah, thanks for that close-up. That looks odd to me. I see it's fork. I think it's forking at the end, not coiling. And then there was that odd little branch that curled off the side there. And what I said for those listening, I noted to Rian in the chat, one of the things we're trying to determine is whether when we see these whips that have these side branches, if these branches look natural, that is, where the branch arises from the skeleton, can we see any evidence that there was some prior damage and that there was regrowth, and the regrowth has caused, an aberrant new pathway of growth, that is, it's a branch. Or potentially one of the things that we had hypothesized in the past was that some part of the skeleton got exposed and the larva settled there, and that it could actually be a separate colony growing on the first colony. And so that's the value of looking at some of these interesting observations, because we don't see them all that often. There is a group in the Pacific that is a group of these bamboo coral whip-like species that I think we've pretty much determined that indeed they do put out branches after they get, let's say, 1.5 meters tall, they start branching. And so that's what we're trying to determine, if the same thing is happening in the Atlantic or if it's some kind of response to damage.
Yeah, the pilots were just setting up here, Scott, to have another look at this this particular bamboo. Because you're right, it does seem very odd to have this branch coming out the middle. And what makes it more odd is that all the polyps are all closed up on this branch. You can really see how they're closed up, and you can see those long spicules that Scott has been talking about earlier. So these long, like, needles. And you can just see them sticking out the top of these polyps. Just beautiful.
I think they're being disturbed by the crinoids, but what I'm looking at is where it's connected to the main stem. And notice that it looks really thick there. So I think that this is some secondary growth, and the question is whether it's a natural secondary growth or something else. But those spines, Rian, that you were just pointing out on those closed polyps, those are really long.
They're really long.
Les, I think, is really going to love that close-up.
They are exceptionally long.
Yep.
It's really beautiful imagery.
And once again, like the ones we saw earlier today, the polyps are really dense. Yeah, thank you. We can certainly move on from here. This is some great imagery that we can analyze later.
Thank you, pilots. That was wonderful.
Copy that. All right, video, when you're good. Get lasers on it real quick.
Oh, yeah, if you can see those two dots on the coral there, so those are harmless lasers. They're 10 centimeters apart, and they help us to scale organisms on the seafloor or other seafloor features. And so you can see those are 10 centimeters. So this bamboo whip here is at least 2 meters, if not a little bit longer than that. Beautiful.
Yeah, let me spin. Yep. Whichever you want it. Whenever you're good. Deploy.
Okay, good to go.
Great, nice.
Another one of these really long bamboo whip corals with all kinds of other species sitting in front and sponges. Oh, an actinorous anemone. Can we have a quick zoom in on the anemone in the right-hand quadrant? Kind of mid. There we are. These are really beautiful anemones. They're called actinorous. And they really stand out because the body is a really different color from the tentacles, and they kind of wrap around. Beautiful. See, this one has a very white body and very bright red tentacles.
Video coming in.
As Jason just noted in the chat room, that a lot of these corals are also knocked over. You can see lots of skeletons here, so you wonder how that happens. And it can be from a variety of processes, from something as simple as a fish knocking into it and knocking them over. They can also have grown too large and will eventually crack and break. Interesting little single polyp red on the left-hand side too. That looks like a new recruit.
Yeah, Rian, I was just going to point out that same thing, and I can't tell at this point if that's a recruit of a Paragorgia or an Anthomaspis.
Yeah, I can't either. I was looking at it, and yeah, not sure what that one is. In the bottom.
Sure, but it does suggest that there's a recent recruitment here.
Absolutely.
Talking over you.
Absolutely, absolutely. Pilot, can we actually zoom in on the far left as well? There's a white.
Is it on screen?
Yeah, it's on screen, just in the bottom right. I'm sorry, right-hand corner, not left. Right. There's a little white colony in here. Maybe this is another Acanthogorgia. They certainly have been very, very dominant on this dive so far. A beautiful shot of this brittle star too, draped over this rock. There's long spines on their legs.
Is that what you're looking
That
at?
was what I was looking at.
Sometimes I think I must be getting old if I can't tell the difference between a Acanthogorgia and a bamboo coral. But I thought that was a bamboo at first, but I believe you are absolutely correct.
Yeah, thank you so much, Pilot. It's great.
Actually, multiple colonies.
There is, I think there's one in the front.
2 to 3 up the rock. Yep.
Yep. Yeah, it's really been very dominant on this dive so far. I've seen it in a lot of little nooks and crannies. As we back out here too, you can see all these brittle stars draped all over the rocks, and a lot of that fresh skeleton that's been knocked over or has fallen over from age.
Yeah, Rian, that backs up what we saw in 2005 when we did a dive a little bit deeper on the slope here in Retriever. The Acanthogorgia were really, really dense. There were a lot of colonies, and you know, it suggested kind of like a weedy species, something that gets in there relatively quick. And as far as I know, nobody has ever attempted to age an Acanthogorgia colony, but my impression is that they tend to grow faster than the others. That's, you know, a hypothesis that I can make because nobody has data to prove it. I would challenge somebody to please go out there and age them.
Absolutely, and I'd also love to challenge somebody out there to look at the reproduction on those too, because where we see species like this that are very, very abundant, that tends to mean that they produce a lot of larvae, or maybe they're producing larvae year-round. And so that larvae in the water column then will find somewhere to settle and grow. Oh, I think I see some cup corals on this bottom ledge. Can we have a zoom in on that bottom ledge, please, Pilot? Thank you.
I'll get this comment in fast because I know how much you love the cup corals. But
I do.
Totally agreed with what you just said about the recruitment, the reproduction, and the other thing that we're seeing is that these Acanthogorgia colonies are in multiple sizes, which is telling us that it wasn't just a recruitment a long time ago, but is ongoing.
Yeah, absolutely, absolutely. We're seeing everything from very small colonies of that Acanthogorgia to really big ones, and so there's definitely been ongoing recruitment in this area. And these seamounts too can actually aid in the retention of those larvae as well. So the corals are producing larvae. Some might get caught in currents that are taken off, but others are in these retaining currents that kind of swirl around these seamounts and keep a lot of material in there. Not sure if these are alive or these are dead. The one in the center is definitely a dead. Yeah, these are all actually dead ones, unfortunately. And some of them recently dead as well. So we've seen those black ones. Thank you so much, Pilot.
Yep.
We've seen those black ones that have that ferromanganese patina, and then we see these brown ones like in the middle, and then these two white ones that are more recently dead.
since they're dead, I will follow up, and I'll note that on a couple of those, I saw the little amphipod mud sticks, amphipod crustaceans.
Still seems
some
like
species are able to construct these little sticks out of mud, and then they hang on the end of the sticks and are waving around and grabbing things out of the water column. And then to follow up on that really interesting comment you said about how seamounts can retain some of these larvae, this is the subject of a lot of research, and the degree to which seamounts act as these endemic hotspots for diversity versus as seeding other seamounts. And if you think about it from the perspective of the species and the larva, what's the better bet? When you produce larvae, is it better to stay really close to the bottom and settle where you think, you probably have a pretty good chance of surviving because your parents did and were able to produce
bearing
you, or you get up in the water
degrees,
column and then
speed
get carried off
knots.
to somewhere else, and then take a chance that you find an appropriate habitat at the same depth, which probably means another seamount
Good copy, thank
before you run out of food. So really interesting source of research.
Yeah, definitely, Scott, definitely. Pilot watch lead?
Hey, watch it go.
Yeah, we just had a sea star. Just went out of screen on the right-hand side. Can we have a quick zoom on that one as we go by?
Yeah,
just a snap. Thank you. Hiding behind this Hertwiggia sponge. This is a bright yellow sponge. Has been relatively abundant as well that we've seen, and right in front of a Bathagorgia, one of these. Bathopathes, one of these black corals.
Also, one thing to note before we zoom in, or while we're zooming in, is that we noticed that a lot of these coral colonies are being knocked over, and the bottom shore does look like it's quite unstable. There's a lot of downslope transport of larger material, and you've got to wonder how much of that, a large pebble or cobble boulder will take out one of these coral colonies that may have been there for 1,000 years, but just one boulder can probably knock them out. And, you see these shoots, these debris shoots. We're going to be crossing back and forward into them. It'll be interesting to see as we go up.
Yeah, that's very true, Jason. Very true. Fish, boulders, other material in the water column certainly could have knocked those corals and knocked them off their pedestals here. So Christopher Ma is saying this is a chondraster. Beautiful. And that this is apparently a real-life Patrick from SpongeBob. Does look a bit like that. Beautiful. Thank you so much, pilots. That's great.
Copy that. Lasers there for reference. Keep moving.
Thank you, Bridge.
Oh, over to the left here, we can see there's another area where these corals are getting very, very dense. Almost every surface here is covered in some kind of coral or another. The very interesting large whip in the background that I'm sure we'll take a peek at when we get there.
Yeah, the one dead center.
Yeah.
That's a little out of our way.
Okay.
We could adjust the track if you want to move towards it, or I could view from here.
Let's have a quick view from here, and then we can make a decision as to whether to move over there.
Okay. Video, you want to come on in now?
A really old skeleton. Oh yeah, look at that. Really eroded away. I actually wonder if that's a sponge skeleton. It looks really porous. Interesting. That's a great view. Thank you, Pilot. I don't think we need to move over there.
Copy that.
It's definitely
Video when you're good.
a large feature in the background there. A little fish.
We've, as we're moving to the left there was another one of these transitions there. There was little to no sediment. It was all outcrop. So the environment is changing, sort of on meter scales, which appears to, really influence the bottom, those benthic organisms and which ones are there. The area we're looking at right now, it seems a little more devoid of the larger colonies, perhaps because things are moving down slope and removing them and sediment accumulating, preventing, recruitment and regrowth.
Copilot, can you look at my aft camera?
So
I see something glimmering.
Been a really interesting, last hour or so, just changing from one environment to the next.
Yeah, I do. I wonder if there's some biology that got stuck on the lens.
Can you look, see if you see anything with the PTZ for me? Yeah. Make sure it's not like fishing line or something?
Yep, copy that.
Well, these tall bamboo whips just peeking into the frame here, and another large one in the background there as well. And as this terrain is changing, we're really seeing a little bit of a change in the fauna too. More of these Okeanos colonies.
Try to pull forward. That might
encrusting sponges.
Light.
Beautiful.
Might just be imagination too, but.
No, I saw it as well.
Scott France was mentioning in the chat room that that skeleton we saw maybe was a very, very pitted, a very eroded Paragorgia, maybe?
Try to bring the tether forward.
Or a hemicorallium, very, very large one.
Okay.
Ooh, pilot watch sleep.
Hey, watch it go.
The very bottom of the screen, there's something almost shiny and gold. Just went off screen.
Copy that.
Very rounded to the right-hand quadrant. Still off screen a little bit. Yeah. Do you see that? Very rounded. I assume it's a sponge, top of a sponge of some kind. Yep.
Right there?
Right there. Yep.
Yeah.
Top of the sponge, I believe. My eyes were caught by it looking kind of a glinting gold. It'd be great to have a snap zoom while we're here.
Video,
Thank
do you
you.
mind coming in on the Sirius cam when you get an opportunity? Thank you. That's good.
Yeah, a sponge was fooling me. It had almost the shape of a giant snail shell.
Is that all you need?
Yep, that's perfect. Thank you. More of this Acanthogorgia again, different sizes kind of dotted all around it.
I don't see anything on the football
hemicorallium.
closest to D2.
Could just be smuts on that camera lens too.
I think it might be. Thank you, video. Bringing you back up.
Do you want to center me and then put that camera on your screen and see if you get a better view at all?
Sure. Put the tail cam on my screen?
Yeah.
So just in this one camera view here, we're seeing multiple species of coral and multiple species of sponge. And these are organisms that are often found on these seamounts and are one of the reasons that this area was proposed as a marine national monument. These corals and sponges are really important to ecosystem engineers, so creating ecosystem for other organisms to live around.
Okay, great.
They stick up into the water column and create habitats. And so when we zoom in on some of these corals and sponges, you'll often see lots of other animals living around them. And they're using them for protection from predators. They can hide in those little nooks and crannies out of the way from predators. They also use them to lay eggs and also to have young, and so have juveniles living around these corals where they get that little bit of extra protection from predators. Now, predators can also use these corals as well to find smaller organisms to be able to eat and feed off. One of these beautiful yellow Hertwiggia sponges, along with a big barrel, big tube sponge sticking out of it.
I haven't called the move in yet. Have not. You guys ready, or you want to wait?
See these large coral skeletons that are dead and lying on the sea floor there. As we were talking about a little bit earlier, these could be from boulders and rocks and downward transport of material from the upper areas of this pinnacle. They could also be from larger organisms such as fish, potentially knocking these corals as they swim around them. Or they could be just that the corals have aged out.
Thank you.
That they have got to a size big enough to make them a little bit fragile, and so they will fall over.
A lot of current pushing down, so
yeah, XY popped out.
Yeah,
it's beautiful. It's been a really beautiful scene here on Retriever Seamount within the Northeast Canyons and Seamounts Marine National Monument. It's been really a fabulous dive so far for the biology and for the geology too, I think. Jason, would that be true?
Yeah, I think, it has been different in terms of, what we've been seeing throughout the expedition. The first few dives were on Seamount. We didn't plan to go visit, and they were quite far out, and and had different morphology and different sedimentation environments. Then we went to the Corner Rise, and those were different. And as we've been getting closer back to the margin of the North American continent and to the coast, the east coast of the U.S. and Canada, we're now seeing a different environment with different sediments,
Go ahead and start coming in video.
Likely more organic matter, all providing a different overall set of conditions for the biology that lives here and for the geologic record that we're seeing. So definitely another one of these interesting dives where we're seeing something different than we saw in the dive before and previously. So always good to see something new.
Yeah, and this is another really new and interesting thing to see here. This looks like a bamboo coral that's kind of been stripped a little bit. Its tissue is hanging down. I don't think there's a branch in there.
Yeah, so great view, Rian. Really glad we got this zoom. So a couple of things. One, note the main stalk on the right that's disappearing down. Look how much thicker it is than this part where the tissue is stripped off. And it's almost as if there was a settlement on this much older coral. You can see that the nodes have been overgrown as well. Look how thick they are, and there should be dark nodes in there. I think what's happened is there's a new tissue that's been put over it, a new calcification over the nodes. I really don't know what has happened to scrape that collection of polyps. Often, one thing that's instructive, there's no skeleton in there, but you can see all these polyps are interconnected with one another. The common tissue is called seamenchyme, and so the seamenchyme has been pulled off that newer, thinner part of the skeleton and is hanging down there. The polyps are still alive, and they're still connected to the rest of the colony upwards. So, really interesting observation.
Yeah, really, really fascinating. I don't think I've ever seen tissue hanging off of one of these skeletons like this. You often see those skeletons where they're denuded, but it's very unusual to see them where the tissue is actually hanging down like that. Very strange. Absolute field of these Okeanos, these bamboo corals that have a root-like structure that attach them to the seafloor.
Looking at you, 5-0.
And again, one of these dead skeletons laying on the seafloor with little parts of it still alive, I believe.
You want to come in on this arc feature on the rock?
Yeah, this is a really interesting rock feature here. These little kind of steps down, and there's a little coral. And I think as the coral is moving in the water current, it's creating this little circle around it. Gotcha. It's kind of sweeping the sediment as it's going.
All right, pilot's clear.
Funny.
Cool.
But it's interesting seeing these little steps here, Jason.
Well, yeah, I was wondering if the coral's actually etching the ferromanganese crust there.
You wonder if it could after a long time. Yeah.
Yeah, there's another one up there.
It's interesting how far, the diameter of that etching. I mean, the Acanthogorgia, that was an Acanthogorgia, they're pretty flexible, but that's really flexible. I'm not sure how easy it is to twist the colony.
Yes, is that something you want to get a closer look at?
But yeah, the layering there is interesting. They're very thin layers. They don't. I'm not getting the sense that they're volcanic, perhaps. They're very. When we've seen the volcanic
picking up the slope and
the lava layers, they've been a lot more massive. These ones are very thin and look like they're quite friable or breakable at the ends. And some of them may be ferromanganese crust.
Go ahead, Wesley.
But one of the things that we've been seeing on a lot of the tops of these seamounts is these carbonate platforms, kind of like reef environments, paleo reef, old reefs that are now drowned and quite far below the sea surface. So this is perhaps we're seeing the morphology of those carbonate rocks, which are generally weaker than the volcanic rocks, with strongly crystalline lavas that tend to hold together much better.
Like to see it coming in video?
Very interesting. We hadn't really seen that so far on this dive too much.
Squat lobster?
Yeah, this is a crab. It's almost like a king crab. Very spiny body. These tend to be more elongated than flattened.
Still getting used to this.
I don't think this is a chasion. So I'm willing to be corrected by the chat room. I don't know if it's an interesting angle or whether it's truly lost one of its claws up front. Neolithodes. Thank you, Megan Putz, on the scientific chat room here. Neolithodes. No crab. And that's the first one for this expedition so far. Yeah, a relative of the king crabs. And they're very distinct, so they're less flattened and smooth than the Chasion red crabs that we've seen so far. And they have all these very sharp points and spikes all over their body, which makes them kind of recognizable. And if we look down from the top as well, they're kind of more fat at the back and then more elongated up the front. Beautiful. you so much, Pilot. That's a really great view.
Probably should think about coming up and pushing ahead here soon.
Pilot's clear when video is clear.
And again, like we've been noting the whole way, lots and lots of those ophiuroids, those brittle stars, all over the surface of the rock. You also saw a very small recruit of a paragorgia up top as well. Beautiful.
I'll come up with you.
Copy.
So Scott France and Les Watling were noting here that, although they appear to only have 4 legs, that last 5th pair of legs is greatly reduced and kind of tucked up under the carapace. That 5th pair used for cleaning gills. Beautiful. Oh, and as we come up this rock here, just tons of different species of coral. We have Bathypathes, we have Acanella, we have Parantopathes. Beautiful. And this Canthogorgia that's been really dominant.
Now the ship stopped a few minutes ago, right?
Correct.
Paramaricia.
6 minutes ago.
Great. Thanks.
Beautiful.
I'm definitely still swinging.
Yeah, we're noticing like 8 to 10 minutes of swing.
Copy.
Pilot watch lead.
Go ahead, watch lead.
Could we zoom in on the vase sponges, the very bright white? There's like 1, 2, 3, 4 of them right in front of that rock. Thank you.
Maybe after that zoom, we got to get you up and.
Looking down at me 60. Copy.
Yeah.
So we've seen a few of these beautiful hexactinellid vase sponges. The hexactinellids have a silica skeleton, where the silica spicules, long needles, are all knitted together. It's beautiful. And you can really see those pores. So sponges are filter feeders, so they have to have pores in the outside. And you can really see the structure in these. These are really beautiful. I love zooming in on these particular sponges just because they're so beautiful. They have such an amazing structure. And so inside each of these holes are these special cells called choanocytes that have little wiggly flagella, and those flagella will wiggle together and make a water current. So it comes from the outside through the wall and then out through the top. They can create quite a water current.
Turn up to the center one. We don't have a ton of
Megan
time
Putz
here,
is saying Regadrella for this particular species of sponge. Just beautiful. Thank you so much, Megan.
One of the things that I find particularly fascinating about the glass sponges is that they are effectively just 1 or 2 large cells draped over the skeleton. The construction is such that when a cell undergoes natural cell division, it duplicates its nucleus and then creates a new membrane to create 2 cells out of 1. But in this case, when the nucleus divides, there's no membrane that is created, and so in a sense, it's just one extremely large cell.
It ended 6 minutes, 7 minutes ago.
How do you feel?
And otherwise, as you described,
there
are flagella that are coming out of parts of that syncytium, driving the current through it.
This here?
So
yeah, right there.
From the demo sponges.
Sorry, Scott, to cut you off. I found a cup coral. This one's alive.
I understand. No problem.
There we are. We've seen a couple alive so far, and I was wondering if we'd start to see more. But yeah, so this is another Desmophyllum dianthus, I think, with very red tentacles. This time the tentacles are all retracted in the body. That's great. Thank you, Pilot. It's good to have an ID.
All right.
Beautiful.
Push it forward.
Do you want to continue on the 215 heading?
Which way is it to waypoint
235. Well, we're almost at waypoint 2. I was picking up waypoint 3 at this point.
Copy that. Yeah, general uphill seems to be like a 235.
Yes.
There's one of these Iridogorgia.
Sounds good. I don't.
And a couple of sea stars here as well.
So you're out in front, though.
Yeah, I agree.
Pilot watch lead.
Go ahead, watch lead.
Is it possible to zoom in on these two sea stars? One's kind of in the foreground, one's a little bit in the background.
Sure, if you want to come in.
Thank you. This looks similar to a species that we saw earlier, a contraster. Maybe slightly less bright pink than the one that we saw earlier. Has a little bit more yellow in the skin here.
Okay, come up to the other one.
Beautiful. Thank you, pilots.
Yep.
And then there was a sea star that looked a little bit different in the back here. Oh yeah, longer arms.
So, Rian, I have to point out that in front of that sea star is a Swiftia. That's an octocoral I don't believe we've seen on the expedition yet. Very thin branches, red color.
Go ahead and come in, video.
Oh, great spot, Scott.
I'm not sure if we're still alive. But.
Yeah, great spot. Yeah, so this is a slightly different kind of sea star than the couple that we've seen so far. This one has much longer arms. Thank you so much, pilots. That's great.
That's clear.
I came up a little bit. Pilot, it looks pretty... There's still returns out in front, but it looks
large sponge that we're passing over now. Lots of holes. You can see those larger holes where the exhalant, the water, is coming through. So it's being drawn in through pores in the body. And we see sponges in lots of different forms, but all of them will have kind of a larger pore where the water is coming out, and then these smaller pores where the water is going in somewhere along their bodies. Yeah, really gorgeous here as well. Beautiful, and another sea star. This one was six legs on this sea star.
Please.
Yeah, look at this, a six-legged sea star. So most sea stars have five legs. But this one has six. Little brittle stars on the rock around it as well.
Sorry, video.
You can see the sea star's little tube feet where it's curled up on the main arms. They have these little tube feet underneath. They have a water vascular system, so usually on the top surface they have a little pore called a madreporite, and the water goes in and helps move the arms, move the tube feet. Beautiful. Thank you so much, pilots. That's great.
Pilot's clear.
One of these large Okeanos bottle brush corals in the middle here, and you can really, this is a beautiful one because this really shows why they're often called bottle brush corals. They're just like a little bottle brush. This one's very neat and trimmed, but we certainly see some more during this dive that have a bit more of a inconsistent shape. Beautiful. And there's another one here on the right, which has the crinoids that we've been seeing so many of in this particular dive, sitting on top, perched on top.
Your pilot, camera's 5-0 right there for reference.
Copy that, thank you.
you're just joining us here today, I want to say welcome to Dive 19 of the NOAA Ocean Exploration Expedition North Atlantic Stepping Stones. And the stepping stone that we're looking at today is Retriever Seamount, which is within the Northeast Canyons and Seamounts Marine National Monument. We're very fortunate to be diving today. This dive was supposed to be yesterday's, but unfortunately weather pushed us out, and we're fortunate to be able to dive on this today. This is the last of our benthic dives. The dive tomorrow will be a midwater dive. So this is the last time we're going to see the bottom on this expedition. This dive started today at 1,940 meters, and we're currently at 1,870 meters. So we're actually not too far from the top of this pinnacle feature. We're diving on a pinnacle feature on the north side of Retriever Seamount.
And I don't think we've gotten to the actual video of any of the seamounts. So it'd be fun to get there.
Oh, this is one of those coffin fish. Very rounded body and very distinct markings on the outside.
Gonna be drifting a little bit, co-pilot.
It's funny, I'm not sure I've ever seen one of these swim. Very often they're just sat on the bottom, and you can actually see they're relative to the angler. And look, you can see its lure going. These are called esca. Whoop, off it went. There it goes. Beautiful.
Okay, we'll let him swim away video.
Yeah, so these little coffin fish are relatives of the anglerfish. And you could see that little lure on the top being angled, being fished as it was swimming. Oh, is it going to settle? It might settle.
Do you want to come back in video?
These fish also have very, very wide fins, and so they almost sit on the bottom. There it goes. Beautiful. There, the wide fins are helping it sit on the bottom. This is a fish that generally feeds and preys on the bottom.
Forward.
Using that wide feet to stabilize it. Thank you so much, pilots. That's great.
All right, coming back. Is that full wide video? Thank you.
So Megan Putz is saying that little fish that we were just seeing, the coffin fish, is also known as a Chornocops roseus. Beautiful. Thank you so much, Megan. Oh, and just look at this edge of this collapse feature here. Just absolutely loaded with corals. Really beautiful.
And a fun collapse feature that we can look at too. We see those layers that we were talking about earlier. They kind of form. They're kind of thin, but they're they form an interesting outcrop, and this seems to be some of the area where this debris is breaking off and moving down slope. It's the kind of thing I've been looking for as we've gone up these very angular, broken type outcrops. So then we can see some of the debris at the bottom of the outcrop that have broken off. And,
yeah, go ahead, watch it.
Parts of it have moved down slope, other parts hang around.
Sure.
But then there's this coral on top, which likely some enhanced water flow here at this kind of sharp edge that it's taking advantage of.
Yeah, these corals and sponges are often found on these edges because that's just a place where the flow is often that little bit higher.
Start at the base and make our way up.
And so these can be areas that are swept of sediment a little bit, so larvae are able to grow. And this large colony is something a little bit different, I think. Having a look to see if we can figure out what this particular large colony is. Looking in the chat room, not quite sure. Either a really large Acanthogorgia or Paramaricia. It's a really thick skeleton for an Acanthogorgia.
Start coming up.
Has those large snake stars wrapped around its branches there. You can just see the arms tucked in. See lots of mysids growing around it as well. Scott France is suggesting this is a large plexaurid of some kind, which is a type of octocoral.
Maybe if we bring the
it's really big.
Lower inboard.
Yeah, of course.
Light it up a little. I'm a little bit underneath it right now. Oh, and that's my max zoom too.
So you want starboard lower?
Yeah, if we could have it fully stowed and then inboard.
Copy that.
Yeah, if it's possible to get a closer up of the polyps pilot, that would be great.
Just trying to get some better light on it at the moment.
Yep. It's a really big colony, so it's blocking some of the light. So.
Come over a little bit.
Very long tentacles with pinnules. Very, very dense.
Coming down a little.
I don't think it did anything, Pat.
Copy that.
Yeah, it's a great shot of those polyps there. Those long tentacles and the feather-like structures on the tentacles there, those are called pinnules. Really beautiful.
Is there anything in particular you want to see video?
Yeah, pilot watch lead.
Go ahead.
So this is really unusual, so I think we'd like to collect a branch if that's possible.
Understood.
Thank you.
I'm going to put your arm back out before I forget.
So this particular colony of coral is stumping our scientists on shore, as well as myself. I don't think we've seen anything quite like this before, certainly not on retriever.
Right.
I think maybe it's a plexaurid of some kind.
I'm going to come out and then maybe come around to the
So the pilots are going to set up here to collect a small branch. Just
snip off a part of it.
A small branch to be able to take to the Smithsonian and have it in the collection for scientists from around the world to study.
And we have all bio boxes are available right now. Is that correct?
Beautiful.
I believe so, yeah.
Copy. Alright, lasers on now. It's quite large.
Tracting drawer. Sending pins. Alright, both boxes are ready. Sirius is in a good spot. I think she's been all stopped for a while.
Understood. I'm going to come up and come to the port side of this and get a good toe in, so I'm not reaching up.
Copy that.
Watch lead, I'm looking at some of these branches over here on the left side of it. Is that like right above the lasers now? That might be an option there to go in and snip a little bit off. Is there any particular part you want? Do you want a branching part? Do you just want any part?
I think any part of this particular one. I don't think the branching is going to be useful for taxonomy as much as the polyps are, so, and the skeleton itself. So I think any part that you can easily reach in and grab a small piece would be great.
Understood.
Thank you.
Put your port lower in.
Oh, we do have a request to a piece with a sea star on it. The Astroschema snake stars would be good, which actually that top part that you mentioned has one on.
Copy.
Thank you.
It's quite low.
Lower stowed.
Copy that. Okay, I'm locked in there.
Hydraulics are up.
It's gonna be tough with it blowing so much. I think I can go in, cut out that little one here.
Yeah, I think right in there looks
right
good.
above the left laser. All right.
Yeah, I will put mini Zeus up for you.
Copy, thank you. Yeah, sure. I got lasers off.
So pilot watch lead.
Go ahead, watch lead.
There's a suggestion from the chat room that this is actually, it's going to be quite tough. So it's going to be worth giving it a good cut.
Okay, understood. I'll make sure I get a good section of the jaws.
Perfect, thank you.
Auto heading is not engaged.
Copy. It's engaged now.
And you just might want to rotate a hair clockwise to get some room for the arm. But you look good.
Yeah. Cut over a bit. Yeah, I see what you mean.
It's really blowing, huh?
Yeah, it's moving around a lot. It'll be a interesting grab. I might be able to help hold it still with the arm. All right. Could you come full wide for a bit video just so I can get my bearings? Copy that. Arm's coming on. Arm's live. Alright, now gently grab it as it blows towards me. Lovely fan. So I'm trying to grab a dollar bill flowing in the wind.
Come down on camera a little.
Copy.
Stop there.
How does that look, watch lead? I can get a decent...
That looks perfect.
Sure.
Yep.
Close.
I think it broke off.
Okay, that looks like it's clear.
Expertly done. Thank you so much, pilot.
So that does have a piece of the, or it has a full sea star.
Yeah, if we could get a quick zoom on that, that would be great.
Sure.
And then stow for safety.
Understood. You don't have a ton of light.
Yeah, Astra Schema Sea Star is, Snake Star is tucked in there. Nice.
Okay.
Perfect. Thank you so much, pilot.
No problem.
That's really great work.
All right, do you want to try to open box here?
Do you think we have enough room? We might have enough room.
Might. I can try it.
Let's go for port side.
Copy that. Extending draw now.
Understood. Okay. Do we have something in the port outer? Or
I think it's just some sediment that was stirred up.
Copy that. Go ahead and open jaws.
Nice sink to the bottom. Looks good.
Okay, jaws are clear.
Retracting.
Still, thank you.
Nice job.
Okay, arms stowed. Hydraulics coming off.
Valve pack's off. Pins retracted. HP's off. Put your camera back up.
Copy, thank you. Coming up and back.
Beautiful collection. Well done, pilots. And so you'll have noticed at home that we collected just a small piece. The pilots are very, very careful about selecting just a small branch. And that coral, this magnificent colony of unknown species is left behind to continue to grow. So that's unharmed. Well, we have a piece of that will go into the Smithsonian Museum, where scientists from around the world will be able to take out that piece of that coral to be able to identify and do studies on. Really beautiful collection. Thank you so much, pilots up front.
No problem. Yeah, it's a different camera, right?
Oh, the two. I don't know what's different between them. I know the coloring's different on deck, so there is a difference. The lighting, though, it's mirrored. I could try dimming the mains, but it'll affect anything I do will affect equally the other camera. It isn't. The camera was put on. We swapped.
Pilot watch lead. Can we zoom in on this little bottle brush? It's on the very bottom of the screen, almost center, slightly left of center.
Do I do a snap zoom?
Thank you.
Bottle brush.
Yeah, just a snap zoom. I think this actually might be a Chrysogorgia rather than a Canella.
Coming up a little.
Yeah, I think so. So this is a Chrysogorgia, which is another type of bottle brush coral. Beautiful.
Coming up again. Sorry.
Thank you so much, pilots. That's great.
Pilot, I'm looking at you about 3.6 Sirius cam.
So this looks like a little bit more of kind of a rockfall feature there, Jason.
I'll just come up and
kind of looks like a pile of these rocks have slid downhill potentially.
235.
Yeah, that still sounds good.
Yeah, I mean,
10 or 15.
There appears to be quite a bit of transport here.
And do a 10 meter.
And again, where we see, this transport of the boulders and sediment coming from above. More of those colonies have
Bridge
been
ROV nav.
knocked over and incorporated into
I'd like to request to move 10 meters, bearing 235 degrees, speed decimal 2 knots.
Skeletons, twigs, and other things that we see.
You can see good out 20 meters out.
Good copy, thank you.
An interesting accumulation of sediment here, nice and thick, but seems to be relatively consistent grains, perhaps being swept up against this little exposure here, where parts of the rock are broken off.
And
it's really interesting geology in terms of trying to figure out what it is that we're seeing. Are we seeing these crusts? Are we seeing layers of carbonate? Are we seeing different thin layers of volcanic material? We have a couple of rocks now, so hopefully we will be able to perhaps answer, or at least start to answer some of those questions. But, if another one of these outcrops where material has broke off the edges and started to move down slope.
Yeah, and on these edges, these can be areas where water flow is just increased just ever so slightly, and that water flow can both take away sediment and also helps to bring in nutrients and food to the corals and the larvae that might settle there and grow. And so that's often why we see more of these species kind of growing on these edges than necessarily on the faces or sometimes on the top. Though I admit today, on today's dive, we're seeing an awful lot of coral species and sponge species that are also sitting on top of these rocks as well as just on the edges. Some previous dives, we really would only see them on the edges, but this dive has definitely been different. This is quite an extensive, highly diverse, and a high biomass community that we've encountered today. Been absolutely beautiful to be able to observe this area of Retriever Seamount for the first time.
Yeah. Can I take the Cirrus scan, point it down real quick? Just do a quick tether check. Yep. It's in a good spot while you're pulled out there.
Thank you, Bridge.
Pilot Watchley?
Go ahead, Watchley.
Can we zoom in on there's a red coral colony right on the edge. It's kind of mid-screen to the right, kind of on the crack.
Sure. Go ahead and start coming in video.
There you go, yep. It's pulling more towards center.
Copy. Upper.
There we go. There's quite a lot of interesting things on this rock surface here.
This...
Yeah, that one right there. So I think this is another Paragorgia bubblegum, just a very, very small one. Thank you, Pilot.
Sure. Pilot's clear when video is.
It's always interesting to zoom in on those features because we also saw some snails there. Some hydroids, some bryozoans, and some little worms as well. Lots of other organisms also living on these faces of these rocks, these cracks areas where that flow might be a little bit enhanced. Oh, beautiful red crinoid. Gorgeous. So a lot of the crinoids that we've seen so far have been kind of that brown and yellow color. We've seen a lot of crinoids really in abundance. And here's a beautiful red one. These crinoids are echinoderms, so they're related to the sea urchins and sea stars that we're seeing. And we can see ones that live on stalks that have a stalk, but other ones like this one actually have little legs on their back, and those legs are used to grab onto rocks or sometimes onto sponges and other coral colonies. Beautiful. And a Chrysogorgia off to the left as well as some dead cup corals on there.
Constantly pulling out. He's just seeing a lot of current.
Beautiful.
Reen, can we have a look at the white colony that's just in view on the bottom now?
White colony on the bottom.
It's probably to the right now for you. We're looking at it on it.
Oh, actually on the very bottom of the screen. Kind of central. Yeah.
The little one?
Yeah, the little one.
Go ahead and come in video.
Yeah.
No, I think I'm too delayed. I mean the fans that are on the edge of the rock.
Fans, yeah, so this is a hemicorallium. So let's zoom out again, please, Pilot. Sure. On the edge of the rock, fans.
Yeah, so above this, yep.
Okay.
This, hemicorallium. So on the edge of the ledge, just to its
kind of a pink
o'clock on what we were just looking at, the hemicorallium.
Okay.
The large colony.
The large colony, kind of a peachy color rather than white. Is that right?
Yep.
Yep.
Well, yeah, I thought one was kind of white, one's peachy. Maybe both the Acanthogorgia. I'm trying to find this Candidella.
Yeah, if we could zoom in right here, it's central, so this big long colony.
Go ahead.
Yeah.
Yeah, the closer we're getting, the more I'm thinking it's quotes, just another.
that Acanthogorgia has been so so present on today's dive. Thank you so much, pilots. That's great.
Sure.
Yeah, thank you for that. And not just present, but it keeps fooling me because it's such a huge range of sizes and shapes.
It is. It is. It's really abundant. I mean, I can see 4 or 5 of them just in this one screen right here. Thank you so much, pilots.
Yep.
Yeah, some look more yellow, some look more brownish, some look more peachy, as we just saw there. At least the ones that we have collected in the past, they all seem to be the same species. They just seem to take on different colors, perhaps as they age, perhaps something to do with what they're
but I don't know if
feeding
I
on.
actually moved anywhere from that last move.
Do you want to get another one?
Yeah, indeed. We don't truly understand why some of these corals have different colors than others. And in fact, some species can be a variety of different colors. We have species of scleractine hard corals that can be both yellow, red, and white. And we don't truly understand why that happens. Like, why are these organisms different colors in the deep sea?
That looks good. I wonder if, as we approach.
Yeah, you see the same thing with, I think it's Paragorgia arborea.
It's definitely increasing at
white,
bottom.
red, and pink.
Yeah, it's really fascinating. I mean, a lot of organisms on the deep sea are often red or some form of red, so oranges through purples.
Meters,
and they do this because red is attenuated very, very quickly out of the water column. So as you go deeper and deeper, you can no longer see the color red. And so this really protects you from predators.
Good copy, thank you.
But we don't truly understand why some are some colors and some are others. Like, why is this Herdwigia sponge that we've seen throughout this dive, why is that one bright yellow and other sponges are white or even purple dark colors?
Oh, it's 82
it's really,
meters.
really quite fascinating and
it's
still
a
really big question.
Yeah, because I was going to say, I didn't think I was moving. So as we approach, it might just more current, just increasing way back. What's the
2.3?
Good copy, thank you.
If that's what you were asking.
It was, yeah. Spot on.
He's quick on his current events.
These outcrops are kind of looking like they have a pillow lava texture and overall morphology to them. So these are the first ones we've seen so far that have that more diagnostic morphology. So these pinnacles may in fact be maybe these late stage volcanic features that have been preserved for a really long time. Over them being some carbonate cap or some other feature. So.
Yeah, it's very fascinating because on the very top of Retriever, there are a number of these features. These are little pillars that are sticking out from the very top of the Seamount, and we just picked one in the north today to be able to dive on, but there were several on top of this feature, which is really fascinating as to what those might be, and they're certainly looking very volcanic, very pillow lava-like as we climb further up here. Beautiful polymastia sponge. I really like these particular sponges. They look like little hedgehogs on the seafloor. Really beautiful. We get a species of these polymastia in the Gulf of Maine, not far from where I live and where I'm based at the University of Maine. The beautiful array of different species of coral here that we've been seeing as we've gone on our transect here. Oh, really beautiful view. And actually, if you turn over to your live stream number 2, you'll be able to see the view from the Sirius camera. So we're diving a 2-part ROV system. The Sirius camera is the part that's connected directly to the ship, and then D2, the part that we're primarily looking out and being able to collect from, is connected to Sirius. And so Sirius is there to take a lot of the wave action out, and so we don't get affected by the waves and the heave on the D2 part. Now, the Sirius has a fantastic camera on top, so we can look down onto D2, and it's a really great way to get a sense of scale in some of these features. And so right now you can see D2 working its way up this very pillow basalt type wall, and all of these corals and sponges really standing out in front of it. Just beautiful. And every time I think that the corals can't get any more dense on our drive up this cone, they do. There are more and more colonies appearing out of all angles. Just amazing. One of the reasons that we're interested in diving on this particular little volcanic cone today was both the depth. This is a great depth for lots of species of deep sea coral to live. But it's also a cone feature, and these cone features can increase the water flow and kind of circle the water around them. And when we see that circling of water, we often see that larvae are transported and food is brought in and retained in these areas. And so we wondered if this was an area where we'd see a lot of biodiversity. And I would say that those hypotheses have been true. On this dive so far, we've seen a lot of biodiversity, particularly in corals and sponges. Really beautiful. Pilot watch lead?
Go ahead, watch lead.
Is it possible to look at the very at the bottom of the screen where it's like a collapse feature? It looks like a little cave.
Copy.
If that's not too far away.
Should be able to take a look at that.
Thank you. I think there were some cup corals growing on the edge, as well as some more of this acanthogorgia.
You're still moving, right, Copilot?
Yeah, slowly. I'm looking at U35 though, so.
Understood.
Beautiful.
4.5, which would be a better reference. That's 4.5 right there.
And Megan Putz is reminding us that when the Okeanos Explorer, the Dive Retriever in 2019, I'm not quite sure what vessel that one was on, was so dense with sponges and corals you could barely see the bedrock. Sort of that's been our experience with dives on Retriever as well. That each of the dives at slightly deeper depths than we're doing today have all come out with very high biodiversity dives. Yep, Okeanos Explorer, so the Okeanos Explorer in 2019. Yes, more than
after this zoom, sorry, if we could look to the right, I saw what looked like a whip, but very different, not a bamboo whip, and I'm just wondering if it's a crinoid without the head, or if it's a primnoid whip.
Okay, yeah, we can take a look. A little squat lobster stuck in the crack here. And this almost brain-like sponge.
Coming on this whip over here on the right, I believe that's what he's talking about.
I think this is a bear stalk, Scott. I think it's of a crinoid. It looks like the stalk of a crinoid. Thank you so much, Pilot. That's great.
Copy. Right, pilot's clear with video of this. Drifting. Yep.
Yeah, Acanthogorgia and Acanella here. Oh, actually, it would be great, Pilot watch lead.
Go ahead.
Can we zoom in on the base of this Acanella? It's dead center right now.
Sure.
But the base, I just think, has a really beautiful holdfast that I caught as we went by.
Go ahead, video.
These Acanella have very interesting holdfasts. They have almost drippy, like, root system, and they can live in sediments, but also on rocks. And this is just a great example of that. You can really see those roots having calcified onto the rock here. We have this bottle brush coral, Acanella.
Yeah, current jumps around on me here. Trying to get a feel for it. Yeah. Alright, pilot's clear.
Very nice. Thank you so much, pilots.
Camera is 6-0 right there for reference.
Push it forward.
Beautiful view here as we're working our way up, and this is dive 19 of the NOAA Ocean Exploration Expedition, North Atlantic Stepping Stones. And the stepping stone that we're looking at today is actually inside the Northeast Canyons and Seamounts Marine National Monument, and this is Retriever Seamount. And this is the shallowest dive done so far on Retriever, and we're certainly seeing a repeat of what a lot of the other dives on Retriever have seen in these high-density coral and sponge communities, and we've certainly seen that today. It's been just a wonderful dive so far.
Hey, this is Brittany Peterson again with the U.S. Fish and Wildlife Service and Superintendent of the Northeast Canyons and Seamounts Marine National Monument. I'm glad to be back. It really has been an amazing dive and allowing us to kind of explore the creatures that are on Retriever and setting us up for having a better understanding of how to best manage this amazing place and the biodiversity that survives here, thrives here, and everything that moves on through. I'm very excited to have you all exploring and investigating in this amazing, wonderful monument.
Nav 1924.
Just get around this and then push forward.
This is incredible. Look at all these corals.
A lot of coral debris, actually. I think this is like the first real thick accumulation of significantly older coral debris that we've seen so far on this dive. Seems as we're getting towards the top, these debris piles are getting a little bit bigger. But the morphology here, the shape of the seamount as we go up is just really interesting. These caves are getting more, we're seeing more and more of these little caves or collapsed features, whether they're collapsed pillows or collapsed low bait flows, something.
2.4 knots now.
2.4, yes.
And these sharper edges where a lot of the rock debris that we have been traversing up seems to be
facing a good heading, so this is just having trouble keeping it still.
These really kind of sharp, breaks, but very rough.
4-0 right there.
Here's a good one where we're seeing really big blocks that have broken off and just kind of tumbled down to.
Jason, sorry, could I just interfere for a second? Before we go too far, there's a coral just off the screen to the upper right. If we could have a look after we look at the rocks. Thanks.
Which one, Scott?
Ahead of you.
The Iridogorgia?
Well, it's behind the Iridogorgia, and it looks like a flat radar dish from this angle, and I just want to be certain that it isn't a Metallogorgia. It might be, we're looking head-on into a Metallogorgia, so if you can see that, no need to go over.
Go ahead, watch too.
I think maybe that is what's going on. It's waving a bunch. Okay, thank you. We don't need to look at that any further.
I'll have lasers on if you want to steer me towards it. Lasers are on now. Okay, go ahead and come in, video. Copy. This guy here. Yep.
All right, Scott?
Yeah, thank you. I had said it. It's a Metallogorgia. We're fine.
Okay, great.
There's a radar dish-shaped prim NOAA that is only known from, I think, 2 specimens, both seen on retriever Seamount. And so I've been trying to keep my eye out for that today.
That's really cool. It's always really interesting when something is so endemic in one little local area. And a pretty exciting thing to learn about that the Seamount hosts some that are like that.
Absolutely. So one of the things that I'm really excited about that I'm seeing, everyone talk about the rich diversity and the abundance that we're seeing. We had this hypothesis. One of the reasons that we wanted to explore this part of the Seamount and this particular pinnacle feature is we predicted that it would be a really good place for suspension feeding organisms, and we thought the closer we got to the top, the more dense it would be, and this is what we're seeing. And so, credit to the Okeanos Explorer program. It's given us the opportunity to see more and more seamounts and more bottom communities that allow us to make these predictions. And so then when we come down here and we see that that's borne out, it's going to allow us to tie into what we see in all the mapping that's done and make predictions from those maps and the ancillary data like temperature and oxygen and so on. So terrific dive today.
Nice big heave there.
Thanks, Scott. I definitely think if your hypothesis was that this would be a great place for filter feeders of corals and sponges, I think that has been proven correct. This has been a fantastic site.
Yeah. Should line up well.
Once Sirius is there, it is a good heading, I think.
Yeah, it's 235 now. Yep.
There's coral covering pretty much everything you see in our field of view right now.
Yeah.
Bridge ROV
There's also a couple in the center there, those sort of pinkish colonies. They
I'd
look
like to
like a whole
request to
series
move
of
range
F2
15 meters, bearing 235 degrees, speed decimal 2 knots.
Pretty frequently today, and these are really quite large colonies. So it's also impressive to see not just the abundance and the diversity, but the size. It tells us that things are doing quite well here and have been doing well for a long period of time.
Yeah, that's always exciting when you see the really large colonies, like we saw a little bit earlier today too. But one of the things that makes me really excited when we go to sites, you actually see the small corals, showing that they're actively continuing to recruit and that they're growing. The community as a whole is growing, and you see a bunch of different sized organisms from super small and young, juvenile, all the way up to those really, really large colonies. It shows you just how healthy of a community this is.
Absolutely. It's so critical to the healthy community and the longevity of that community.
Jason, so you were talking a little bit before about sort of the pinnacle on top of a seamount that we're exploring that we've just been saying, is certainly our hypothesis has been correct here that it's a great place to host biological communities. But what would have caused a pinnacle like this to form geologically to create this kind of environment?
There's a number of potential, mechanisms. We could go with, the constructional type mechanism, which is volcanism. Obviously, these are seamounts. These are volcanic products, and we can certainly, generate features on the summit like this. Usually at the very end of some eruptive period for the seamount, would be very late stage, and right at the end of the constructional kind of period. The other option is that it's formed by later erosion and destruction, essentially, of the seamount as it continues its journey across the seafloors as the plates move and it moves away from the hotspot. It starts to be eroded and fall apart, just as a natural process. And in that case, it could be that there was a carbonate cap on top, and that was eroded into these forms, or a volcanic top to it was eroded. So there's a number of potential mechanisms for doing that.
I watched too.
I think from the morphology we see on.
Yeah, I'm just flying around, so if you see anything in particular, let me know.
Is really great.
Okay.
It looks like they are, sort of late stage volcanic features.
Thank you, Bridge.
Others would argue and could argue. I could probably argue that the bathymetry says it's erosional, but I think putting the ROV down, we're seeing these pillow basalt, these pillow lava morphologies, these broken open type features. Earlier on, I was going back and forth on whether or not we were seeing some of these carbonates, these limestones that we thought we might see. But now that we've come up a little further, certainly seeing a lot of what could quite possibly be these collapsed pillow lava. So,
center.
Still up to learn, even though we've visited this spot a couple of times now over the years.
What do you want to focus
Still a lot
on?
of unknowns. Hopefully the samples we've collected
straight into the center where that
research
is
from around the world, we'll be able to use them to learn a little bit more.
Left of center.
Sort of test some of those hypotheses on what we're seeing.
I think I lost my toe. Stand by one.
Holding.
Yeah. Okay.
Slight tilt down.
Coming down. Holding there. Do you want more?
Yep.
Coming down. Continuous.
So you've got quite a few associate organisms here on this bubblegum coral. You have a brittle star, which you can just see kind of wrapping its arm around the stalk here. And then you also have a couple sea spiders and a brittle star in the background.
Tilt up.
Potentially two different types of brittle stars. This is pretty cool. This is a pretty thick. Go ahead, Scott.
Sorry,
no, go ahead.
I was just going to say there are a couple of species of different ophiuroids on this Paragorgia bubblegum coral. One of them that we very commonly see, the one we're seeing now, the snake star, I think it's Astroschema is the genus. But then we did see one a little bit before that had very spiky arms.
Continue up.
Those ones aren't quite as common on the bubblegum corals. Might be Astronix, or not Astronix, Ophioptynthaka, something like that. This is a very large colony. Must be quite old.
Pulling out slow.
All the polyps are withdrawn, though. You can see the lumps. You can see how it gets the name bubblegum coral, look like water bubblegum. But the tentacles are all retracted.
Looking at you 3
down at the base.
Plenty of time.
Coming down.
This is beautiful. The pilots are going to get lasers on it in just a second, but you can just see how big and thick these branches are. How quickly do bubblegum corals grow?
So I'm not sure, because of the nature of the construction of the skeleton, I don't know that anybody has attempted to age it in that way.
Still one full screen without
but
the
I have in the back
Cover.
of my mind, and I'm not sure exactly how they did this, but ages of something on the order of 300, 350 years for a very large Paragorgia colony.
Bottom of the screen.
But again, I don't remember the specific paper I read and how they did that aging.
Hold there.
Hold it.
Is the transition from that pink color down to the white base pretty typical of the bubblegum coral?
No, I think what you're seeing there is that the tissue at the base is dead, and so the white is the underlying skeleton, and the pink is the more live tissue. Excuse me. The paragorgiids are a little bit different from many of the other corals that we've been seeing today, in that the construction of the skeleton is more like a concrete, and so the sclerites, these are the microskeletal elements that are made of calcite, get embedded with tissue and all kind of cemented together. And so there is some tissue actually in that skeleton. That's not just inorganic. Is the word I'm looking for. It's not just an inorganic skeleton. So it looks very different from other things that we've been seeing, but basically the live part of the tissue does have that pink color. And Les Watling, I guess I wasn't paying attention. Les Watling just pointed out that coral I've been searching for, Candidella imbricata, there was a colony right there at the base, and it's the one I think that has all of the brittle stars aligned along the top of the colony, which is a very common observation for that Primnoidae coral.
So, of course, we feel very fortunate today to be able to be diving in the Northeast Canyons and Seamounts Marine National Monument. And I think we have Brittany Peterson on the line, who is the superintendent. And I'm wondering, Brittany, whether you can give us an overview of the Marine National Monument and what that means for areas like this of deep-sea corals.
Yeah, absolutely. So I'm Brittany. Let me introduce myself. I am Brittany Peterson with the U.S. Fish and Wildlife Service and superintendent of the Northeast Canyons and Seamount Marine National Monument.
How's my nav?
The first one in the Atlantic. Marine monuments are a newer concept that was started under the George W. Bush administration with the Papahānaumoku Marine National Monument out in the Pacific Northwest.
Your internet was telling you about an hour. Let's see. We're at 1850?
The Northwest Hawaiian Islands. But by putting these places aside, especially with the 4 seamounts within the Seamount unit up in Northeast Canyons and Seamount Marine National Monument, as well as the Canyon unit, this is helping to preserve this type of habitat and ecosystem so that researchers such as the folks on this call and in the field can continue to study this mysterious place that we know is abundant with life, nutrition, and everything else that can really produce in this underwater,
an exciting dive from what I understand.
Rich environment, but allows us to better understand what happens over time. One of the most interesting facts when taking this position and learning about the Marine Monument is that a lot of this area was exposed land at one point, and I got waypoint 3 selected here. It looks like from Sirius, migration back to bearing 237. It really serves as
what's the range on that?
A path forward for us understanding as things begin to change.
Sirius to the top of the hill is 170
one day, or maybe not.
Okay, so we got a little room to run.
Yeah, so this place is just one of the other amazing things. This is right off the coast of Cape Cod and New York and all the places that we typically think of as bustling metropolis. And
it's
130 miles, pretty much the length of crossing through Massachusetts. On I-95, you can be out here via boat in the Marine Monument and experiencing not only the biodiversity that we see under the water, but the biodiversity that exists on top of the water.
Yeah, when I landed, there's quite a bit of current. Is there still a lot up here?
Quite a bit, the abundance of fish and prey species, or the marine mammals that congregate here because of
that's why all these animals love it here.
Access to. There really is a unique location and a unique space right in our Atlantic backyard.
Yeah, thank you, Brittany. It's one of the things that I really enjoy about this, too, is that this marine monument is not just the surface waters where we see the enigmatic whales and turtles and the puffins, although those are amazing, but also all the way down to the seafloor, and we see all these deep-sea ecosystems that are being preserved as well. And just to give a sense of scale, the Marine National Monument, I'm told, is about the size of Connecticut. And so this is a relatively large area in the Atlantic coastline here that's been protected. So that's just amazing to be able to dive there today. Thank you so much.
Copy that.
Yeah, and great reference. That is a great visual reminder. Yes, it's about the same size as Connecticut, which is just incredible to think about.
It is. It definitely is. And it's amazing to come down and explore too. There are 4 seamounts within the monument, and these 4 seamounts, although they have been visited several times, are still what we consider to be really underexplored. We still are seeing areas like the one today that we have never visited before, and we're seeing for the very first time. So beautiful. So for those of you just joining us, we're on Dive 19 of the NOAA Ocean Exploration Expedition, North Atlantic Stepping Stones. And as we were just talking about, the stepping stone we're looking at today is Retriever Seamount within the Northeast Canyons and Seamounts Marine and National Monument. And it's just been an amazing dive so far. So we are currently at 1,848 meters, not too far away from the tip of this pinnacle on the northern side of Retriever. We started today's dive at 1,940 meters.
Awesome.
And we so far have just seen an amazing array of deep sea corals and sponges and other fauna as well on this pinnacle in Retriever. And so we've been incredibly fortunate to be able to study this and explore this area today. And as Scott France is noting in the chat room too, that we're also fortunate that we had a really dedicated group of scientists and managers who really pushed for this monument to be preserved in 2016. And so a huge thank you to everyone who pushed that proposal forward to create this special area that we're looking at today.
You want 15 more meters? You want to wait a minute?
Let's see. Co-pilot's got me at about 40 degrees. Yeah, I think we could probably get a move in if she's comfortable with it too.
What do you think, co-pilot?
Yeah, I think so.
Oh, pilot, watch it.
I think.
Go ahead.
Can we zoom in on the large sponge in the middle, but it's covered in this purple coral?
Yeah, copy that.
I believe this is more of that royal purple clavularia coral, but it's actually encrusting a sponge this time. We've seen it encrusting coral skeletons.
I was going to do another 15 meters.
But this is it encrusting a sponge here. You can just see the hole, the exhalant hole of the sponge out front. And on the edges, this coral is growing over the side of it. Now, we don't know whether the growth of this coral is really impeding the sponge, but I can't imagine that it would be terribly good for it. Sponges are filter feeders, so they need pores to be open and be able to bring water
This is
in.
RV nav.
And so this coral growing over it, I can't imagine it would be a good thing. Though we don't,
looks like same as last. 15 meters. That's, that's 15 meters, bearing 235 degrees,
Thanks
speed decimal 2.
Pilot clear.
It's a good copy.
So I don't know if you all heard this, but I was told playback's been increasing with the current as we've been going up this, so just keeping an eye on that.
Yeah,
it sounds like
It's interesting, Jason, we've kind of come up on this area a little bit further up, and now we're seeing a bit more sediment in between these kind of plates and even some sediment waves here.
Yeah, again, pointing to that, the influence of the currents and the oceanographic processes, even kind of right up towards the tip of one of these pinnacles. There are still opportunities for the sediment that is primarily being drawn out of, the water column, the shells and pests and other things of the marine organisms that live in the water column, and when they die, they fall out and they start to accumulate on the sea floor. Even in an area that there isn't a lot of room for that accumulation to occur, we're still seeing that. And, there is this constant process of moving the material from the tops of the seamounts to the bottom. Sometimes it takes a really long time. Sometimes the sediment never even makes it to the bottom. So we're really seeing, this continued mix of of deposition and reworking of the sediment. And the current moves, resuspend sometimes some of the sediment, and
go ahead, Watchley.
It can be trapped in various ways. So still an interesting amount of this gravel material as well. And whether that is all
just send it up to this current here.
Material that's coming from the seamount, or that are being dropped from icebergs as they melt as they go along, these ice rupted debris or drop stones. That is all possible as well. We're getting quite shallow, so there isn't much more seamount above us. So at some point we'll only be seeing stuff that's coming from above, and that's the water column.
So this is a really interesting interaction here. We have an urchin that's been climbing up this tall bamboo whip coral, and you can see below the urchin it's all what we call denuded, so all of the living material has been stripped off of it, and up above it the bamboo is still alive. And so the suspicion is this urchin started at the bottom and has been munching its way up the top of this this bamboo coral. These urchins are predators of these corals.
Yeah, this is a really interesting observation, Rian. I'm kind of shocked, actually. I wasn't convinced that the Okeanos were feeding on some of these bamboos that we've seen them on, but boy, this sure looks like what's been going on.
I think this urchin has been caught red-handed, in fact.
Yeah. Yep.
Yeah, this urchin definitely seems to
Aristotle's lantern.
Red Aristotle's lantern. Yep. It's been munching its way up. So these urchins have their mouth parts are called an Aristotle's lantern. It's a series of 5 really hard teeth that are in the very center of these urchins, and that's what they use to feed on, to feed. And so this urchin has been using its Aristotle's lantern, and you can see the polyps very close to it are all retracted, and further up they're a little bit more out, and you can see those sharp spines. So this urchin must be able to get around those sharp spines. It doesn't seem to affect it whatsoever. Beautiful.
I was going to say that does not appear to be much of a defensive mechanism from what I'm seeing here.
Not for these urchins, for sure, for sure. And of course, big question by Ken Sulak here is how long has it taken for this to happen? And the reality is we really have no idea how long this urchin has been here or how long it's taken to feed. It's really just beautiful. If we could zoom to the very bottom of this colony, and then we can be done, pilot. Thank you.
Roger that.
You can see these beautiful nodes. These nodes are what give the bamboo coral its name. So the white parts are calcium carbonate skeleton, and the black are this proteinaceous, what we call nodes.
Thank you, Bridge.
Here it is, curly-whirly, all the way down to the bottom. Oh, and up again.
Trying to throw me for a loop here.
Yeah. It's like one of those puzzles, those rings where you can't touch it, otherwise it goes buzz. Oh, a little double node there.
Very interesting nodes.
And not much in the way of biofouling, which suggests that maybe this hasn't been denuded all that long ago. I guess the very base there is a little bit biofouled. But yeah. Oh, and a sponge in the way of the base.
That's an interesting...
If we need to get a clear image.
So that's an interesting observation, Rian, about the biofouling. But the other interpretation of that is that it was biofouled but was cleared off by the urchin.
That's true. Yes, that could be potential. Maybe the urchin isn't eating the bamboo coral itself. Maybe it's eating things that were biofouled on it and has done it fast enough that nothing has grown in behind it. You know, these are the kind of observations that really can only be done by things like long-term cameras. And so, you know, as a scientist, I would come down and put a camera on the seafloor watching this urchin and taking time-lapse video, time-lapse images over very long periods of time. And, you know, we have seen downed coral colonies with urchins on them before. And come back a year later, and those urchins are still there feeding on that coral colony. So these processes definitely take a very long time.
It is the sort of thing that we need to do, and I feel like a defense lawyer for this urchin. I keep trying to make it.
You do.
Moral, but this sure looks like a smoking gun.
It does. It does. That's a great interaction to a film. Thanks so much, pilots.
No problem.
One of the joys of exploration cruises are not just finding new species or new locations for species, but is also observing some of these interactions that we usually wouldn't get to see. So traditionally in oceanography and marine biology, to sample the deep ocean, we'd have to use things like grabs or trolls or dredges. And so you'd end up with this collection of animals on board the ship to then kind of sort through and figure out species. And while that gave us a really great amount of information about what lived in the deep ocean, it didn't really tell us things like how species were interacted together. By the time they'd come up to the ship, everything would be jumbled together. And so this way, being able to have video and be able to zoom in on some of these interactions, we're really able to see some of these for the very first time.
Okay, this has got my antennae up.
That's a good copy.
I thought it might.
This is weird.
Go ahead, watch. Sure. Yeah, if you don't mind coming in slow video.
Yeah, this looks like a jumbled hot mess, Scott.
My heading's
yep.
Hot mess bamboo. Yep, parts are missing and parts are growing out of all kinds of angles.
Going for this big junction here, watch lead.
That's great, thank you, pilots. Oh, it's actually, look at that. So there's a junction, there's a fork, but then actually it's this branch is curled around this other branch, and maybe it's rubbed away the tissue.
Oh, look at that.
Interesting.
Hooked itself.
I'm telling you, I really believe that these whips that have these forks and root branches, every time well, not every time, but very often, how's that? It looks like there has been something that has interrupted the tissue that then you get some regrowth that leads to these aberrant branching events.
You kind of wonder where you see these two pieces of skeleton joined together. So it looks like the polyps have rubbed and they've annoyed each other and they've all rubbed away. And then you wonder if those two pieces of skeleton are going to fuse together. Are they going to calcify together over time? It's really, really interesting.
And then that double node is also unusual. You pointed that out on the last one as well. It had a double node like that.
Yeah. Really interesting.
You know, I've only been studying the bamboo corals for about 25 years now, so clearly that's not enough to know what's going on.
You have at least another 25 years left, Scott, apparently.
Do we have any interest in looking at the
yeah,
base watch?
Thanks, I hope.
Far left copy, come on out a little bit video.
Yeah, more curlies, and we have these crinoids living on top.
I can just trace it up here, actually.
Yeah.
I think there's a junction
here.
here.
There's another junction here as well, and it looks like another one up there as well.
There. Yeah.
Interesting.
And then right above it.
This is Junction City here.
I'll leave it.
Another place where it's been rubbing.
Yep, and then more of this potential rubbing of the polyps together. Really interesting. Thank you so much, pilots. That was great.
Very welcome. Pilots clear. Take your time, video.
Coming wide.
Maybe this is why they don't branch, because when they do, they start rubbing against each other and ripping their tissue off.
Right. It certainly seems like that's potentially what's happening here, where those tissues are interacting together. They really don't like it.
Yep.
Looks like we got a little bit more tether now.
Well, Swatling says this is a fitting way to end a dive series with a bizarro coral.
By what?
You can see.
Yeah, this one is definitely a bit bizarro, that's for sure.
You're saying we don't have tether?
No, I'm sorry.
Ken Sulak also makes a really interesting observation that something similar happens with mangrove rhizomes. So that would be like aerial roots, I guess, of
yeah, it can be tough
mangroves.
on these days.
Normally they never branch unless they're bored into
good.
by a particular invertebrate. And then branching happens right where the injury has occurred. So that's a really fascinating comparison.
That definitely is. Yeah, that's absolutely fascinating. You definitely wonder if that's what's going on here.
Is that a hemicorallium we're going over there on the left?
Yes, yep, we just went by that one. Yep. Yep, a large hemicorallium. Oh, these beautiful long whips. I'm definitely kind of moving into a slightly different topography and zone here. It's more sedimented. I see some sediment waves, some pebbles, some outcrops. And still seeing a lot of the large fauna and any hard bottom that's there. But yeah.
What's your sense of how close we are to the top?
So it looks like we still have about another 20 meters, 30 meters or so, 30 meters before we would reach the top.
Vertical, you mean?
Yep, vertical. So we're actually really quite close to the very top of this cone feature. Peter Oster is putting in the chat here his hope for a fish towards the end of this dive too, and I will note that there haven't been a huge amount of fish on this dive, which I know for me was a little bit unexpected. I thought at this depth we would see a bit more in the way of fish fauna.
That bamboo coral appears to be holding out a flower to the ROV.
Yes, a little crinoid flower.
Pretty sandy over here.
Yeah, really interesting difference in seafloor morphology here. Moving away from the hard bottom and now into little outcrops that are poking through the sediment.
20 meters this time, or?
And we reached an area similar to this a little bit further down the line.
I know yesterday they suggested if we were going to reach the
If you
top
wanted
too
a
soon,
good
we could
visual
kind of lateral
representation
around
of
it.
how
I don't know if
important
that
the
was
bottom is
discussed
to the
today or
community,
not, though.
I
We
think
have
we've just had it.
36 minutes left on bottom.
Do you think
What,
that'll line up?
140 meters
Sorry, by
from
that
the
I mean-
waypoint?
Yeah, we can probably keep moving straight at it. If that's
The
the
organisms
case.
living on the bottom, how drastically it
Or we
changes.
can move slightly diagonal.
From that exposed rock to the more sedimented
westerly.
area here.
Yes, absolutely. Yeah, and where we see these outcrops,
Yeah, we
we're
could
still
probably do
seeing
another one at
that Acantha
225 there.
gorger, some of these
20 or 15?
Paramerissia, and
Probably
these
do
long
20.
bamboo whip corals. And then in between, we're
Bridges
not seeing
over
any of
now.
that larger fauna. It's just too mobile a
Yeah, they
surface.
can move 20
For all these really
meters,
long-lived
bearing
and slow-growing
235
corals, and so
degrees,
instead
speed
we see
decimal 2.
smaller organisms in fauna that are actually living inside the sediments instead. So just because we see these areas without these large corals doesn't
Good
mean
copy.
that there isn't anything living there. Is actually incredibly important organisms living in the sediment, turning them over, bringing carbon down and oxygenating sediments. And so these can be small things like sea stars and brittle stars, but also even smaller organisms, microscopic worms and small crustaceans. Lots of organisms live in these sediments, even if we're not seeing the larger megafauna, those larger corals living in these areas. Now, a little bit further down slope, we did see some cup corals living in the sediments, which was really fun to see. And so I wonder if we might see some of those as we reach this patch again. There are certain species of cup coral that do live in more sedimented areas. But you know, even though they're living in sedimented areas, their larvae do still tend to settle on small little tiny pebbles, and then eventually the coral kind of outgrows that pebble, or even the pebble grows into the bottom of the coral, and the coral appears to be sitting in the sediment itself.
Keep an eye out for some fish.
Pilot watch loop?
Go ahead, watch it.
Can we zoom in on the white coral? It's just gone off to the right there.
Sure.
Thank you.
Coming into center.
Or sponge. Could be a sponge.
Copy that.
Rian, to follow up,
You
I'll
gonna come on
note
and slow it
earlier
down and
we
try to
were
sit
also
down?
seeing some sea pens in the sediment, and I haven't been seeing those up here as well.
That's right. That's indeed.
Latter half of the dive.
Yep, indeed, we were seeing a bunch of sea pens. Yep. Oh, it's a little tiny corallium. Thank you so much, Pilot. That's great.
No problem.
Yep. Beautiful.
Crab friend.
I'm scanning this area to look for those sea pens and those cup corals in case there are any, like there were a little bit further downslope. That was really fun to see those cup corals. Most of the corals that we've seen today have been octocorals or black corals. And these are types of soft corals where the skeleton grows on the inside and the tissue is on the outside. And the cup corals and hard corals, these are ones where the skeleton is on the outside and the tissue is actually primarily found on the inside. It can kind of retract into its skeleton. And the cup corals are solitary, so it's a single polyp, whereas if you've noticed when we've zoomed into all of these corals, there's lots of polyps all living together, and these are clonal, so all the polyps are genetically identical to one another, whereas the solitary corals are genetically distinct.
Water column there. Oh, he's a fast guy.
Pilot watch lead?
Go ahead, watch lead.
So coming into center on a pebble, there's potentially a cup coral. Kind of in between these two bottle rush corals on the right-hand side.
Copy that.
Bottom of the screen there.
I think I see those little whitish guys.
Yeah.
Yeah.
It might be little sponges, or again, little hemicorallium like that last little one was.
Just a little closer here, get some lights on it.
Yeah, I don't think those are cup corals. It's something else.
Can we zoom in video? I'll take a quick peek.
Interesting little organization of species. Actually, it was a cup coral. It's just an old one that has died and left its skeleton behind. Oh, you can see some beautiful polychaetes in there and some sponges. And this little tiny colony, probably an Acanthogorgia.
Go ahead, Bridge.
Brittle stars. And that's a really good, that's perfect, Pilot, thank you. That's a really great representation of just how much is on this,
Chris is going to look at the
kind of
wire right now to
surface
see how we're looking.
that is just very small, and we have to zoom right in to be able to see. Oh, and it looks like we're coming up to another rocky area. If you go to your live stream number 3 and look in the bottom right-hand box, you can see a little screen called the Blue View, and this is a forward-looking sonar that the pilots are using to have a look and see what's coming up ahead. And very bright returns are hard bottom, things sticking up, and you can really see this rock formation. It's really nice to compare what you can see out of D2 on live stream 1 and then what you can see out of that Blue View sonar. It's really great to compare the two. It's a great tool. Really beautiful.
So that should move complete now?
Yeah, it just completed.
Roger that.
Looks like Cirrus starting to swing. Lay back, 75.
Copy. Can we go for a snap zoom on this object in the center here? So the sponge.
Yes, this is one of these polymastia sponges. But I'm actually really interested what is above it to the left.
Copy that. We can get eyes on it.
Yeah, this polymastia sponge is one of my favorites. These are little sponges that look almost like little hedgehogs. Oh, it might be a juvenile one potentially. Look at that. I don't think I've ever seen a small one. But it certainly has the same kind of morphology on these long tendrils, these long almost tentacles sticking out. Really interesting. Ah, beautiful. Yeah, if we could zoom out slowly from this edge, because I think there's just a lot of things growing on this edge. I see some clavulera, the bright purple encrusting coral. I see, of course, the Acanthogorgia that's been so abundant. I see some cup corals. I think they're all dead. I don't see any live cup corals here. But relatively recently dead. They're very white as opposed to the really black, dark encrusting ones. Oh, no, there is a live one left hand of the screen underneath that bramble bamboo.
Go ahead and take it video.
Beautiful. Oh, what a great view. Yeah, so this is one of those cup corals. So throughout this expedition, we've seen these really large stands of dead fossilized cup corals that are all blackened and covered over with that ferromanganese patina. And here is a live one. We haven't seen many live ones, but we've seen a few so far on this particular dive on Retriever Seamount. Just beautiful. You can see that hard outer skeleton, that white, and those bright red tentacles.
Copy that.
Waving in the current, waiting for particles of food to go by. Thank you so much, pilot.
No problem.
Beautiful. All these bramble form bamboos here. And all kinds of acanthogorgia, just lots of things growing on these rock faces. Just beautiful.
Full wide.
And these scleractinian hard corals can be really important. When they're alive, they form important habitat. They have very hard structure and often grow groups. That one is a solitary, but often they grow together. But when they die, they actually can form really important paleorecords. So collecting fossil corals can be really important. Some of those fossil corals date back 10, 20,000 years, or even up to 250,000 years, I believe, is one of the oldest that's been collected so far. And that will tell you, the skeleton's made of calcium carbonate, which absorbs different markers of what the water is like that they grew in. And so by looking at these fossil corals and coral skeletons, you can have a look at what the water masses in this region were like 10, 20,000, or even 250,000 years ago. So they just form really important recorders of climate. Beautiful. Really beautiful view in front of us here. We have the hemicorallium. We have Acanella bottle brushes and beautiful barrel sponges. Lots of those ophiuroids all on the rocks. And they've been pretty abundant throughout this dive. And wow, just look at the number of brittle stars on this hemicorallium here, absolutely covering it. Really beautiful.
Curious about that.
Watch this, you got 25 minutes left on bottom.
Thank you, Nev.
Can we go for just a quick zoom on the center there video? Curious about that guy over there.
Pilot, I have you at 50.
Thank you.
50.
Copy
I
that.
saw one of these earlier. These are cool, aren't they?
Yeah.
Like the dark
Beautiful
red and white.
Actinorus anemone. These are really beautiful. The outer is white and the tentacles are red, and the way that they contract in kind of creates these ripples. That central area is their mouth. You can see it's all puckered up. And those tentacles, these are cnidarians, and so the tentacles have something called cnidae or nematocysts. These are cells that have specialized barbs inside them that when something goes by, those barbs shoot really, really quickly and they become sticky. And so this way they capture prey and bring it in. If you've ever been to a touch tank in an aquarium and you've reached out and touched the anemones and they kind of stick to your finger, they don't really hurt, they just stick. But those are those nematocysts, actually those little barbs going into your finger to make the tentacles stick to them. They're just beautiful. Great shot, pilot. Thank you.
Copy that. Pilot's clear. Thanks for the zoom.
Oh, more cup corals. They're alive. Over to the right-hand side of that underhang, I think there's actually a group of them.
Copy that. Go ahead and come on in video.
You at 56. I don't know if we want to move back. I don't know if I'm...
Absolutely beautiful. 1, 2, 3, 4.
Stand by. Actually, he come out just partial video.
And these, I believe, are the Desmophyllum dianthus, which are
here.
really abundant in this area as fossils and a little bit rarer as live. Just beautiful.
So have a hotter return to my starboard
I think
side.
there may be a black coral whip just above and to the right of the cup corals.
Yeah, a really thin one.
Very narrow, thin
That's
whip.
a little bit better.
Yep.
You can come on in video. Let's try to get the cup corals again.
Yeah, just beautiful, big, long tentacles, a little grouping. Now, if you saw some of our earlier dives, you would have seen mass groupings of these all growing with one another, forming massive walls. There's actually some juveniles there too, I think. 1, 2, 3. Yeah, so there's been a recruitment event here relatively recently, over several different recruitment events. One for these larger ones that we're seeing, and then one for those 1, 2, 3, 4 juveniles on that rock as well that are very, very small. Oh, and that's cute. You can see two little claws sticking out from underneath the rock. We have a little squat lobster sticking out the bottom.
Watch, we need to move here, I think.
That's okay. Perfect. Thank you so much.
Come on up here.
You've satisfied my need for cup corals.
Copy that. You can always look at more.
We're certainly starting to see more as we're moving up, and I wonder if that's down to the morphology a little bit. There's more of these caves, and very often these Desmophyllum dianthus cup corals like to live kind of on underhangs of caves. Like as we go by here, I can see several on the underhangs as we're going by here as well.
Coming up, co-pilot.
Coming up with you.
Thank you.
Another one of these beautiful hemicoralliums covered in these brittle stars. And these brittle stars are suspension feeders, so they like to be up into the water column, and they'll be stretching, often seen stretching out their arms in kind of a fishing position, collecting particles and collecting prey items from the water. And so being up on these corals is a way to get them up into the water column. Oh, here's some rope, some anthropogenic rope there on the seafloor.
We may have already passed by it, but it looks like there might have been a fish in one of those corals just back a bit. Or it looks like there is an eye there.
Interesting. Unfortunately, I think we might have passed it. But yeah, we just passed a little bit of fishing gear as well, Brittany.
Mm-hmm.
Yeah.
Yeah, it's amazing how interconnected, whether it's coming from rivers and runoff or just through activities in the ocean, how prolific the human fingerprint is on these deep sea environments.
Yeah, absolutely, absolutely. I think it's something definitely to remember that, the ocean is all connected together, and I think on the surface ocean has the potential to end up in the deep ocean. And we were seeing that in our earlier dives with that sargassum. We were seeing masses of sargassum around the ship. And when we dove, particularly on Gosnold Seamount a few days ago, we were seeing masses of sargassum down at, 3,000 meters. So everything is all connected together.
Absolutely.
You guys want to turn to starboard a little bit and line up with it, or looks like according to Sirius sonar, it's a little bit starboard
Beautiful
now.
black corals here.
That,
uphill.
Like 245 or so.
Yeah.
I think I'm getting back out in front of co-pilot here, just a little bit. How are we looking, co-pilot?
You're at 50 now.
Just beautiful, these rocks. Kind of come into an area with more, looks like a lot of downslope transport of rocks. Smaller and larger pieces as well, as we're coming up towards the top of this feature, just like 10, 20 meters away from the very top here.
Yeah, like 250 something like that.
It has to be when I can't see the video or the good rocks come along.
I know, I'm sorry, Jason.
Yeah.
So Jason is having problems with his video.
I'm just going to look up real quick. I think 250 sounds great.
Back on
Is
Cape
it
Cod.
a huge colony?
Looks like it.
Whoa.
That's okay, Jason, because a massive black coral colony just came into view. It'd be great to get some lasers on that, please, pilot.
Pivot around this whip coral here.
Why don't you take some pictures of the top for me so I can look at it?
Don't you worry, we're taking pictures.
To that.
Oh my goodness, this black coral is enormous. Could we have some lasers, please, pilot?
No problem.
Thank you. It's a telopathes.
I've never seen one that big before.
So I can't even see the lasers. Where are they?
Yeah, we'll get a zoom in just a second.
There they are. So if you look and see two red dots, these are harmless lasers. They're spaced 10 centimeters apart. And they help us get a sense of scale of things that are living on the seafloor. And you can see the scale of this massive telopathes. I mean, this is at least 1.5 meters, if not more. Gorgeous.
That's a big
Absolutely
colony.
Gorgeous. And you hear me call it black coral, but of course this coral that we're looking at is orange. I haven't gone crazy. It does in fact have a black coral skeleton, and that's where the black corals get their name from. And their skeleton, which is very dark, deep jet black. You can just about see those two laser scales in the middle there, 10 centimeters. This must be one of the largest black corals I think I've ever seen. Absolutely beautiful.
Curious how big the base is.
Yeah,
and Scott France is mentioning that, you know, this particular Telopathes does get large, but it may be the largest one that he has ever seen as well.
Look at the size of that.
I mean, look at
base.
it like next to D2.
You can see in the middle there, empty branch that's covered in what looks like barnacles. I think once we do a sweep here, we'll maybe have a couple of quick zooms in. Just beautiful.
Zoom out.
Or you can have video can zoom in on your camera too, Anya.
Yeah.
Watchley, would you like a particular zoom on anything? The base, perhaps?
The base would be good. Could we zoom in on the white associates kind of in the middle, which might get us a view of the polyps at the same time?
We'll start with
Thank
that.
you.
Come on in, video.
Video.
Just beautiful.
He can zoom right after this for you.
Yeah, these look like little barnacles that are growing. Barnacles are crustaceans.
Stationary, co-pilot.
When they settle as larvae, they actually stick their heads onto sticks, so they're actually head down and butt up. And they're sticking their legs out, so those features that you can see there that kind of fan are actually their legs, their feeding legs, and they're also capturing particles out of the water column too, so they like to be up into the water column and have attached to this this part of the skeleton that's missing its polyps. And you can really see the black there as well. That's the black skeleton that black corals get their name out of. So another feature of the black corals that always at least keeps my eye, you know, makes me confirm that it's a black coral, these big long drippy tentacles, and you can see that they have these long drippy tentacles here being moved in the current. Just beautiful. That's fantastic. Thank you, pilot. It'd be great to look at the base.
A little bit of heave on Sirius today. Might get sick if I watch that too much. Ooh.
Trying to adjust with the tilt.
Can we come on out, video? I'm going to acquire the base and we'll go for a zoom. We're still partial, all right? Oh my goodness.
I think you're very close.
My auto's drifted in a little bit, so back up just a little bit.
Look at the size.
If you look at live stream number 2 right now, you can see that we've crept in close to get a really good view of this this amazing black coral, this Telopathes that we're looking at.
Super clear.
Yep.
The minutes and the rails, so I'm going to scoot over just a little more here.
Oh, Scott France with a nice fun fact here. This species was described in 2013, and one of the paratype specimens, so one of the specimens that was used to describe the species, actually came from Retriever Seamount at a deeper depth.
This will hopefully give a view on it.
And it'd be good to get those lasers on the base if we can.
Yeah, roger that.
Oh, a great view out of Sirius right now. If you look on live stream number 2, just how large this coral is compared to the 11-foot high D2.
Going for the base.
Look at that base. It's really stretched out and swept all over this this rock here, and even taken over a part of another coral colony that's grown on it down below. Beautiful. And there are the lasers on that base. So those lasers, again, they're 10 centimeters apart. They're harmless lasers used to help us identify the size of different seafloor features and organisms living on the seafloor. Really beautiful.
One of the interesting things I'm seeing here on the hold test is that you can see that it can put up, I think, new stocks. I think that's what I'm interpreting.
It's either new stalks or it's grown over something. It's hard to know which of those two it is. Yep.
Exactly. Yep. That's why you heard a bit of hesitation in my voice there. Do I really want to say this?
That's great. Thank you so much, pilots. That's wonderful. Yep. Absolutely stunning. What a great find in the last 10 minutes of this dive. That was Telopathes magna. And you can really see where the name magna comes from.
Let me go for maybe one more. Or, and we're stationary, correct now?
Yeah.
Copy that.
May I call one more in or stay here?
I think we can get another one in.
Okay. What range do you want?
What are you comfortable with, co-pilot? Another 15 or 20 meters?
15 or 20 is fine.
Yeah. Let's go for 20.
What bearing? What's your heading?
I think we're doing 50.
250 degrees. Speed decimal 2. Stand by 1. Bridge, this is RV nav. Yeah, we'd like one more move, please. 20 meters. That's 20 meters. Bearing 250 degrees. Speed decimal 2. That's a good copy.
So these black corals, like other deep sea corals, grow very, very slowly. So unlike corals in the upper ocean, they don't have zooxanthellae. They don't have a photosynthetic algae that lives in their cells. Up in the upper ocean, those symbionts can photosynthesize and give the corals lots of energy to make them grow really fast. They grow in the tens of centimeters, if not larger, per year. But down here in the deep sea, they don't have that photosynthetic algae, so these corals grow very, very slowly in the region of just millimeters per year. And so put that in context of the coral that we've just been looking at that's well over 1.5 meters high. And that's just an amazing amount of growth. That colony is easily a few hundred years old. Just beautiful. Yeah, Hertwiggia yellow sponge, and then another type of sponge, kind of looks a bit like an elkhorn. We were fortunate.
Little fish here.
Oh, a little fish. Yeah, there we go.
We can go for a zoom here.
That would be great. I think this is another little coffin fish.
Oh, hey, buddy.
I don't know if it was trying to catch something or whether it's... He's running
faster than I can track. There we go.
Beautiful, and these are related to the anglerfish. They have a little angler on the front of their head. Swum out of view with the second one that we've seen today.
Camera shy.
He's not ready for school picture day.
No, I was not interested in having his photo taken.
That was a bad school of fish joke.
Oh, John. That was a good shot of that black coral, John.
Which, oh yeah,
the big one, yeah.
That
was definitely the largest black coral I've ever seen.
Massive, yeah. Lucky find. It's beautiful.
Minutes.
Copy. Thank you, Nav. It's a nice little geology formation here.
This is an interesting little, or large I should say, looks like a kind of lava flow, pillow lavas that have come down and then broken off towards the base here. We see the corals lining the edges of this cave. It's very often where we see a lot of corals and sponges that those edges form nice areas where they get enough water flow to keep away sediments and enough water flow to bring in food and nutrients to those areas. Though we're certainly not seeing any lack of corals that are living on top of these rocks as well today. The Okeanos in the top right-hand corner, we can see those beautiful drippy roots. We've seen a few of those today. You can see them just edging their way downhill. Beautiful.
Would you like a zoom or are you okay?
A quick zoom would be great. Just a little snap.
Go for zoom.
So,
is it these little guys?
Still seeing lava morphologies this shallow on the Seamount. What is there, like 10 meters left?
That's right.
That, to the summit, that we definitely know that it was where we are would be the source of those lavas.
That's a move complete. Thank you, Bridge.
So often when we're on the Seamounts, we don't get to see, kind of where things came from, just because they're so big and we're looking at such a small piece. It's hard to kind of get a sense of where things came from. So just kind of cool that we're like right where it came from.
Yeah, we're definitely.
Stage
Oh, is
That's
that
another big one.
What is that?
Oh, wow.
Might be out of our reach.
So as we're coming to the top of this feature, we're definitely starting to see much larger, older colonies. We saw that giant Paragorgia earlier, the bubblegum coral, and then we came across a giant Telepathes black coral. And as it comes into view here, I'm really intrigued as to what this particular giant colony is as well. It's like the land of the giants up here on the top of this pinnacle.
How much feather do we have to planet?
Still got some slack.
Hard to tell with the current pushing it.
Yeah.
Beautiful.
Just inch forward, let me know if you feel pull.
Ooh. I'm feeling pull regardless, but I'll keep an eye and see if it starts getting taut on your end.
Yeah, sounds good.
So far on my list, throughout these dives, I keep a little running total of coral species that I see during a dive, as well as sponges and other species. I'm actually up to 28 species of coral that I've seen so far in this dive, with just a few minutes left of our dive now.
There was some
and that's just an amazingly high diversity.
Geology up ahead.
Yeah, that's a great number. Boy, what a wonderful spot we saved for last.
Go ahead,
for the last bottom dive.
Not
I think
at the
that
moment. Yeah,
that large colony may
about
be
as close as
similar
we
to
could
the
get.
one we sampled earlier, the Plexaurid or Acanthogorgia.
Copy that. Yeah, we'll give it just a second to settle from the ship move.
Yeah, it's a really great number, Scott. It's definitely been a very high diversity coral garden environment for much of the dive today.
A fork to send me off?
Maybe. Maybe.
Okay. Might try to make one last push for that big coral.
6 minutes.
Yep, that is.
6 minutes, yeah. So
yeah, and as we, climb up this feature and we're starting to see these larger forms, this could be a factor of there being less material being down transported, so less rocks coming down from above disturbing colonies. We saw a lot of those coral branches that had either just been broken or had been broken some time ago. And so being higher up on this pinnacle, being more towards the top, means there's less chance of something coming down and knocking you off your perch or breaking your branches. And so this could be why that we're seeing these larger forms as we get towards the top of this pinnacle.
Attempt number 2 here, watch lead.
Perfect, thank you, pilot.
I don't know if you'll be able to get a full
Try and have a look at this next giant and see what this species might be.
Come on in, video.
Oh, and the sea star.
Be about as far as we can get right now.
Oh no, this is an interesting one.
Yeah, I think my colleague Les Watling here called it from a distance. He suggested this was going to be a J-clade bamboo coral, and I believe he's correct.
Wow, a J-clade bamboo that's this large.
Yeah, so Jasonisis type. Yeah, another giant. First of the day. Fantastic. Up your list there, Ian.
Yeah, definitely. 29. And I don't think I've ever seen a Jasonisis quite as large as this one. It would be interesting if we can possibly get some lasers on there as we back out.
Roger.
Are you repeating yourself now?
Am I repeating myself?
You said that about a black coral.
Did I say?
It's the largest one. It's the land of the giants here, is my point.
Yes. Yes, it is. So those lasers there, they're 10 centimeters apart, so you can see the scale of this bamboo coral. That's got to be at least 2 meters high. My goodness. I think we can just about see this coral in Sirius as well, if you go to live stream number 2. Really gorgeous.
Pivot a little just so.
Copy that.
Do a view and
yeah,
coral.
let's swing around this to give you a little more tether slack.
The size of that holdfast. The main branch coming up that forms this colony is incredibly thick.
So everyone at home can play the game as we move around here and look.
Got 3 minutes.
Roger that.
Where
So
what's
after this
happening
shot,
at the
you
branch
can
points?
back up the swing arms and come up.
Or are they coming from the white part of the skeleton?
You know, it's very hard to even see nodes on this one, Scott. It's so well calcified on those thick branches.
Absolutely, but I'm pretty sure I saw one on the first zoom in. Video? Not at a branch, I just mean a node.
Yep, I see some nodes. Can't quite see if they're branching. Well. Yeah, I think they're...
Branch point. I'm looking just below the lasers, between and below the lasers. That looks like an internodal branch.
Yep, I would agree. I would totally agree. Internodal. The nodes are after the branching.
Yep. Oh, cool. So this is probably then D-clade. Take back to J-clade. It's a D-clade, possibly keratoisis of some kind. Magnificently large colony.
Okay, probably start stone swing arms.
An amazingly large colony of keratoisis. Beautiful.
Concur.
And such skinny little nodes for such a large bamboo.
Go for a quick look at the base.
Actually, this is going to be our last view of the dive. We're going to start packing up and heading up in the next minute or two. Yep.
Look how thick that base is. Just absolutely covered in polyps as well.
Yeah, it's a stunner. It's so thick that the polyps look like, you know, they're in miniature.
Yeah, and Les Watling's actually mentioned on the chat room too that we saw this large skeleton that I couldn't quite figure out what it was, and he suggested it was maybe a dead skeleton of this.
Unbelievable.
Yeah, it's got to be 6-7 centimeters thick at the base there. That is an incredibly old bamboo skeleton. And what an amazing sight for our last little view of the top of Retriever Seamount. I'm afraid that we have to end our dive now. We've had such a great time visiting this really special area within the Northeast Canyons and Seamounts Marine National Monument, and this giant bamboo to send us off on our way. So I want to say thank you so much for joining us today on Dive 19 of the NOAA Ocean Exploration Expedition North Atlantic Stepping Stones, and thank you for joining us in this exploration of Retriever. I want to say a big thank you to the crew and pilots for keeping us in the water today, and also to all the scientists working from home in the scientific chat room and helping us to identify seafloor features and organisms on today's dive. This is the last benthic dive of this expedition. Tomorrow's dive will be a midwater dive, so please be sure to join us then. Thank you so much. See you tomorrow.
F5.
Thank you, everybody at sea. Thank you, everybody at sea, for making this really exciting dive possible.
Yes, thank you everyone for adding to our understanding of this marine monument and helping share the beauty of it to everyone who's out there.
Let's go ahead and come up a little bit.
Good copy, coming up.
1926.
Push out just a little bit. Coming up with you.
Bridge is RV nav. Just letting you know we're coming off bottom right now.
Laterally into your view. Trying to keep up with you.
Trying to spin to you. It's not very happy about that. I think the current is stronger.
Yeah, roger that. I'll come to you. There we are. Thank you, video. Tether's looking good. Let's get just a little higher off the bottom here, and then we can line up. Alright. If you want to keep going and get a delta Z of about 20, this will be fine. It's looking good, co-pilot. Alright, it's about 20. I'm gonna slowly start backing. Just keep me in your view. Okay,
That's
see,
90.
Looking at me 90. And I believe I need to come to the port. Is that correct?
That's correct.
Copy that. Turning to port.
See the tether on your brow?
I do see that.
Is it above your brow?
It is. I just push down a little bit. Yep.
Okay, good. Great.
And pushing forward. Pushing down a little bit more. Yep, it's above us.
Okay.
Some kind of jelly there. And then pushing out.
I'm going to range your blue view out to maximum.
Copy that.